Okay, welcome to this video where we're going to be having a look at the higher AQA topics that appear on the 2022 Advanced Information List. Now, as you can see on the screen, I've got all the topics here that appear on paper 3. Now, if you want to download this checklist, you can go into the description, click on the top link, and you'll be able to download this for yourself and print it off. As well as that, you can go into the description and you can download the actual paper copy for the booklet for all of the questions that I'm going to be going through. Now, obviously, you need to remember that for each one of these topics, I am going to be only going through one or possibly two types of each question. So you do need to make sure that you check out more in depth into that topic, and I will show you how to do that using this video. So let's have a look at that now. So when you're on one of these videos, of course, if you click on the description, at the top there, you've got the two links that I was talking about. You can download the checklist and you can download the free practice booklets. Now, if you scroll down further, you can see that next to each topic or next to each question that we go through, there's a link to a full lesson going through each one of those. So for each topic, you can go in, you can practice multiple different types of questions. As well as that, if you pause the video and click on the chapters down the bottom left, sometimes you do have to refresh the video in order to get that, but you should be able to get that there. So click on that and it'll bring up a chapter by chapter going through each one of these topics. So if you've already gone through the video, maybe you want to revisit a few of these questions, you can click onto the chapters and you can scroll through and pick the one that you want. So hopefully that's useful and helpful. Please don't forget to like the video, don't forget to leave me a comment and let me know, and we better get started. So 24, if I do that as a product of prime factors, I'm going to do these quite quickly. We get 2 and 12, 2 and 6, and then 2 and 3. Okay, and again we circle all our prime numbers there. 108 is a product of prime factors, not quite as nice, but if we halve it we get 54. So 54 and 2, half of 54 is 27 and 2, 27 is 3 times 9, and 9 is 3 times 3. So we've got our product of prime factors there, circling all the prime numbers. Now if we write out both our lists, let's have a look. So 24, we've got 3 2s and a 3. So 2 times 2 times 2 times 3. 108 is slightly longer. Let's have a look. We've got 2 2s and 3 3s. So 2 times 2 times, how many was it? And then 3 times 3 times 3. Now to get the highest common factor, all I'm going to do is I'm going to have a look at what's in both of them. So in both of these lists here, they both have a 2. They also both have another 2, so they have 2 2s each. And then the top number, the 2 times 2 times 3, there's a 3 in there, and there's also a 3 in the bottom. So in both those lists, we have 2 times 2 times 3. And if we multiply those numbers together, 2 times 2 times 3, just in one of the lists, not all 6 numbers, just these 3, we'll get our highest common factor. 2 times 2 is 4, times 3 is 12. So our highest common factor there is 12. Okay, so it does take a little bit longer, but it does help just to avoid missing any of those factors that we might have done when we were writing a list. So pens come in packs of 8 and pencils come in packs of 20. If we want to buy the same amount of pens and pencils, how many packs of each do we need to buy? So again, we've got pencils come in 20 and pens come in packs of 8. So if we find the lowest common multiple of these and see what we get. So for 8, for the pens, let's label this pens and pencils. And pencils comes in packs of 20. Okay, so 8, 16, 24, not 36, 32, sorry, 40, 48 and so on, but actually I've just spotted there that 40 is going to be our next one in the pencils. So we're going to have a look. 40 is our lowest common multiple, but the question said, I'm just going to highlight this, how many packs of each do we need to buy? So having a look at this, the pencils, that's on the second pack, isn't it? So 2 packs of pencils. And if we count along on the pens, we've got 1, 2, 3, 4, 5. So 5 packs of pencils. There we go. Now, to be fair, with this question, it said how many packs of each do we need to buy if we want to get the same amount? Now, you could have kept on going, actually. If we keep going on the pens, we'll get to 80. If we keep going on the pencils, we'll get to 80. So we could buy double each. We could buy 4 packs of pencils and 10... sorry, I've written pencils for both of them, haven't I? That should say pens. There we go. So 5 packs of pens. So what we could actually do is double both of them. We could buy 4 packs of pencils and 10 packs of pens. And that would still give us the same amount for both. So we're just going to find the smallest one because it doesn't say, but we could have actually kept on going. It'd be a bit silly for us to keep going when we've already found one that gives us the same amount, but there we go. So 2.56 has been rounded to 3 significant figures, right down the error interval. So it's also been rounded there, look, 3 significant figures in this case is 2 decimal places. And I always think when it says significant figures and it's been rounded, I think, well, how else could I describe that way of rounding this number? So 2.56, that's to 2 decimal places. So this is exactly the same as the previous one here where it said 2 decimal places. Okay, but it's been given to us as significant figures, but it could have actually been given either way. So again, right down the error interval, we're going to treat it in the same way. So I'm going to put something in the middle, and you don't always have to have a letter in the middle. I actually could just put 2.56 in the middle. So let's do it this time with 2.56 in the middle. You wouldn't be right or wrong, wrong to do it either way. And then everything else stays the same. So again, getting our upper bound, I just stick a 5 on the end. So 2.565. And then for a lower bound, that's 6 there. It's going to drop down to a 5. And again, just stick a 5 on the end. So 2.55, and then again stick a 5 on the end, so 2.555. There we go. So there's your little trick for doing upper and lower bounds as an error interval. Okay, stick a 5 on the end for the upper bound, and then drop that last number down, and again just stick a 5 on the end for the lower bound. Okay, so this question doesn't actually have the word truncated in there. And if we have a look at this, it says James completes a maths question on his calculator. He writes down the first 3 digits on his calculator screen, and the answer that he writes down is 24.8. Write down the error interval for his answer. So obviously it doesn't mention anything about rounding. It doesn't say he's rounded it to 24.8. So therefore we know it's not about bounds. It's not about rounding with error intervals. This is about truncating, because all he's actually done is written down the first 3 digits. And remembering that the 4th digit there could have been a 9, in which case it would have rounded to 24.9. Okay, but obviously it just says here he wrote down the first 3 digits. So this is about truncation. We'll spot that in the language. This is why this sort of question is worth writing down here for your notes. So that's the number we're dealing with. I'm not going to treat it any differently. I'm just going to put 24.8, which is the smallest it could have been. And then the next number above that will be 24.9, following that pattern from the previous ones. It has to be somewhere between 24.8 and 24.9. And there we go. That's how you obviously can spot in a question that it's actually talking about truncation, not about rounding. Okay, so when ordering recurring decimals and also just normal decimals, we want to just add a few extra decimal places so that we can see exactly what they look like. Now all of these in the first 2 decimal places have a 1 and a 3. So if we go to 3 or 4 decimal places, and we'll think about ordering them from there. So for the first one, 0.13, that would be 0.13 and then 2 zeros after it. For the next one, I'm just going to put a comma in between to separate them. That would be 0.13 and then it's recurring 3s, so it'd be 2 more 3s. For the next one, we'd have 0.131 and it's a recurring pattern of 1s and 3s. So the next 2 numbers would be another 1 and then a 3. If we keep it consistent, then we would want to get rid of that final 3 there, so it's just those 4 decimal places. For the next one, it goes 0.131 and then it's a recurring 1, so that's looking the same as that 3rd decimal, so we're going to have to come back to that. And for the final one, it's 0.13 and it's recurring patterns of 1 and 3, so 0.1313. Now obviously these 2 in the middle here at the moment are identical, but they do have different numbers in that 5th decimal place. So if we write that in, so for that 3rd one there, it was a recurring pattern of 131. So after that 1 that we wrote, it would be a 3. And then for the next one, it was a recurring pattern of 1s. So after that 1, there would be another 1. So that's going to help us just to order those 2. So the smallest, as we start to put them in order, you can see that this one here, our 0.13, is our smallest decimal. So we'll put 0.13, and that's the first one. Now after that, none of them have a 0 in that third decimal place, but we do have a few that have a 1 in that third decimal place. We have those final 3. So just looking at these 3 here, they've all got a 1 in the third decimal place. So we're going to have to look at that fourth decimal place, and as you can see, the 2 that we looked at in the middle there both have a 1 in the fourth decimal place, whereas the third one here has a 3 in the third decimal place, so that's going to go last. So to put this in order, that one that has a 1 at the very end, that's going to be next. So that was our fourth decimal, so that's 0.131 recurring. The next one is the one with the 3 at the very end, so that's going to be 0.131, where there's a recurring 131. And then our final one is this one at the end where the 3 is in the fourth decimal place, so 0.13, and then both of those are recurring. And then our final decimal, the only one we haven't used yet, is this one here in the second position, and that was 0.13 with a recurring 3. And there we go, they are in order. That would be our final answer, and we'll just highlight that. And there we go. That's not very nice there because there were 5 recurring decimals. It'd be more likely that you'd have 4, but that's not to say that you couldn't have 5 if you were going to arrange something like this. And the real nasty part with this question was these 2 just here, where we had to go right up to the 5th decimal place to see which one was bigger or smaller. Okay, so in this question we've got some different options, a lot more words. It says Sadia's going to buy a new car. For the car she can choose one body colour, one roof colour and one wheel type, and she can choose from 19 different body colours and 25 different wheel types. But it doesn't then tell us how many. Which one does it not tell us? It gives us the body colour, it gives us the wheel type, but it doesn't tell us anything about the roof colour. So it says the total number of ways that she can choose these is 3,325. Work out the number of different roof colours that Sadia can choose from. So it doesn't say is it right or wrong. There's definitely going to be 3,325. We just need to figure out then what that number is going to be to actually get there. So at the moment with these two, we've got 19 and 25. So we know that just those we can do 19 times 25. And then we're going to times it by something else. Let's call it x again. And that is going to equal 3,325. So if we work out the 19 times 25 to start with, that gives us 475. So let's just write this down here. So we've got 475 times something is going to equal 3,325. So we just need to figure out what that is, and we can do it in reverse just like before. We can do so 3,325, divide that by 475, and it will tell us what that number is, and this time we should get a whole number, otherwise we've done something wrong. So 3325 divided by 475 gives us the answer 7. There we go, so our answer is 7. So we've got 7, what was it about roof colours? So we can say 7 roof colours. There we go, that she can choose from, and there's our final answer. And just something different here, obviously thinking about it in reverse and making sure that we get that whole number there to figure out what number's missing in our multiplication. Okay, so for this question here it says sketch the graph of y equals 12 minus x squared, showing any points of intersection with the coordinate axes. Now there's one point of intersection we can get straight away, and that's that number at the end. Well, in this case it's at the start, but normally it's at the end when we have a positive quadratic. So that number 12 there, that's our y-intercept. So if we label that straight away, obviously we're not going to forget then, and then we can label that as later on when we actually draw this. Not forgetting as well, it's a negative quadratic, so it is going to be sloping this way, even though we are going to change it to a positive quadratic for the purpose of solving it. So when we go about solving it now, let's have a look. Now again, I am doing a little bit of, I don't want to say a trick, but I am just going to, when I factorise this -1 out, I'm not actually going to write that factor of -1. As I'm going about this in order to solve it, I don't really need to write that. But if I take that -1 out, we get positive x squared. The negative x there is going to turn into a positive x, and the positive 12 is going to turn into a negative 12. And I'm going to factorise it from there. So again, using that same process as before, we can have 1 and 12, we could have 2 and 6, or we could have 3 and 4. And we're trying to make positive 1 in the middle, so that's going to be 3 and 4. So we're going to have positive 4, take away 3, and that would give us positive 1 in the middle. Not forgetting that when it is just an x on its own, that is 1x. So in our brackets here, we've got x plus 4, and we've got x minus 3. There we go. And as we're solving it, let's set it equal to 0. There we go. Now obviously, as I said before, we do need to swap these numbers around. Now the first one doesn't matter, so we can keep that as x plus 4. But we should really swap these other ones around. So when it's factorised, it would be 3 minus x rather than x minus 3. There we go. But we can still get our two solutions from the starting brackets, remembering that you can just set the bracket equal to 0. So when this first bracket equals 0, x equals minus 4. And when this second bracket equals 0, you would get 3 minus x equals 0. Add the x over, and you get x equals 3, just as we would from that first bracket there, just flipping that minus 3 sign over. So we get x equals 3. Okay, so let's get rid of that. We need to actually go about drawing this now. So if I draw just a basic sketch, as it does only say to sketch it, we just need to take into account for the fact that the two solutions, one of them is negative and one of them is positive, and then obviously we have that y-intercept at 12. So I'm going to need to draw the positive and the negative part of the x-axis. We're going to want to go through minus 4 and 3. Don't have to worry too much about the scale here. Obviously 12 would be a lot higher if we had you know, the same scale on either one. But I need my negative quadratic to go up through the y-axis, back down. I just need to label all those points where it intersects the axes. So it goes through here on the y-axis at 12. It comes through minus 4 on the x-axis, and it goes through 3 on the positive part there. So there we go, that's how we would sketch a negative quadratic. Obviously it does say any points of intersection with the coordinate axes, so that includes the x and the y axes, so that's why we've got the y-intercept on there. And obviously that process to find where it crosses over the x-axis is to solve it. So just remember, change all the signs, factorise it, and then swap the pieces over in the bracket. Although if there is a plus sign in there like this x plus 4 one, then it's just going to remain unchanged, but you could write 4 plus x if you want. So we've got two equations here, and simultaneously just means we're going to be solving two of them together at the same time. So in both of my equations I've got an x and I've got a y, and we've got to find the value of both of them. So I've got two equations here. I've got the first equation, which I always just label equation 1, and it's a good little tip here just to label them up. So we've got 3x plus 2y equals 4, and the second one here we've got 4x plus 5y equals 17. Now if we can get one of the letters to be the same value or the same coefficient in front of them, then that is going to help us to then eliminate one of those variables. Now we'll have a look, because we've got the x's at the front, which we can underline, so we could make those the same, or we could make the numbers in front of the y the same. Now it's just personal preference, but I've always just looked at that y value there, the one in the middle. Okay, and I'm going to explain that a little bit more as we go through it, but I'm just going to make the numbers in front of the y there the same. So in my head I'm just thinking, well, 2 and 5, they can turn into 10. So the top equation, equation 1, if I was to times everything in that equation by 5, then the number in front of y would be 10. So I'm going to times that top one by 5. And the one below it, the equation with the 5y there, I'm going to times that equation by 2, and that'll also allow me to get a 10 in front of the y there. So what I'm going to do is, to the side, I'm just going to completely rewrite both these equations, but I'm going to times the top one by 5 and the bottom one by 2. So if I times the top one by 5, we get 15x plus 10y equals 4 times 5, which is 20. And the one below that, timesing it by 2, we're going to get 8x plus 10y, and 17 times 2 is 34. Now I have two options now. I can add these equations together, or I could subtract them from each other. Now if you think about 10y and 10y, if I was to do 10y add 10y, that's going to make 20y. So they're not going to disappear if I add them together. But if I do 10y take away 10y, then that is actually going to eliminate them, and they're going to disappear, and we're not going to have any y's left in our equation. So the way to remember it is, and this is just personally how I've always remembered it, is these little signs here in front of the y's. If the signs are the same, you subtract. So the SSS rule, some like to call it. So same signs subtract. This is going to change if the signs are different. If the signs are different, we're going to add, and we're going to have a look at why we do that when we actually have different signs there. But if they're the same signs, subtract them away from each other. So all I'm going to do is I'm going to take them away from each other. So I'm going to put a little minus sign here, and I'm going to do the bigger equation take away the smaller equation. Now, obviously we've got some different numbers going on here. We've got a bigger number at the end in the second equation, but we've got a bigger x value here in the top one. So it doesn't really matter which way we do it. I'm just going to go for the top equation there, and I'm going to take away the one below. So 15x take away 8x's leaves me with 7x's. The 10y's are gone. 10y take away 10y is 0. They're gone. That's the whole point of what we're trying to do here. And then we've got 20 take away 34, and 20 take away 34 is negative 14. So we've got 7 lots of x, 7 lots of whatever x is equal to negative 14. So in order to solve this, to find out what 1x is, we're going to divide by 7. Just normal solving equations here, and we get the value of 1x therefore has to be equal to negative 2. Negative 14 divided by 7 is negative 2. So there is our first answer. We've got x equals negative 2. Now in order to solve this, we also have to find out what y is. So we just need to substitute this value of x into one of these two original equations up here, 1 or 2. Now it doesn't matter which one you choose. I'm going to choose to sub it into 1, not for any reason, because they both look very similar equations, but I'm just going to sub it into equation 1. So I'm just going to write that down. I'm going to write sub x equals negative 2 into, I'm not going to write equation 1, I'm just going to put 1 there. Okay, so it's quite nice once you've labelled it up, you can just shorthand write in a lot of these things. So subbing it in, we've got 3 lots of x, I'm just going to circle that here at the start, 3 lots of x, so 3 lots of this negative 2, 3 lots of negative 2, is negative 6. And you can write this working out down if you want. I just think that one's okay just to do in your head. So 3 lots of negative 2 is negative 6, plus the 2y equals 4. And now we just need to go about actually solving this. So we've got negative 6, add 2y equals 4. So just like normal solving equations here, we want to get rid of this negative 6, so we can add 6 to both sides. And if we add 6 to both sides, we get 2y equals 4 plus 6, which is 10. And then solving that just like we did with the x value, dividing both sides by 2. So divide by 2 to get the value of 1y, and we get y equals 5. There we go. So we've got our value of x, same sign subtract, made the coefficients of y the same. We've got a value of x is negative 2, subbed it into equation 1, although we could have subbed it into either, and then we solve that again to get our value of y. Let's have a look at another one where there's an add and a subtract in our two equations. Okay, so here we have 2 more equations where we've got a negative in there. We've got 3x minus y equals 4 for equation 1, and we've got another equation with a positive, so 2x plus 4y equals 26 for equation 2. Lovely. So again, I'm just going to have a look at these y values, these y coefficients, the number in front, and we're going to try and make them the same. This is quite an interesting one because in fact I don't really have to change both here, because I can make that a negative 4y on equation 1. So all I'm going to do is I'm just going to times equation 1 by 4, and this happens sometimes where you only actually have to change 1, sometimes we have to change 2, but in this case I can make it a 4 there. Now it doesn't matter that it's negative 4, I don't have to try and match it to make it positive 4, I just have to make the number the same, the actual 4 part. Okay, so I'm just going to make it negative 4 in front. So if we times that all by 4 and rewrite it, 3x times 4 is 12x minus 4y, and 4 times 4 is 16. There we go. And then we're not changing the bottom one, so all I'm going to do is rewrite that below so that I've got these grouped together. So 2x plus 4y equals 26. Okay, there's my 2 equations. Now we subtracted them before, but if I think about this logically, if I was to do negative 4, the one on the top, and then subtract positive 4, so take away 4, I'd end up with negative 8. So those y coefficients, or those values of y, are not going to disappear because I'll have negative 8y if I was to do that. So let's get rid of that because we're not going to actually be able to subtract these. So when the signs are different, we're going to add. So different signs, add. Okay, so when they have same signs, subtract, different signs, we're going to add them together. So let's write that. So 12x add 2x is 14x. Negative 4y add 4y is going to go to 0, they're going to disappear. And then 16 add 26 is 42. There we go, not the nicest one here, particularly if it's non-calculator, but 14 does go into 42 a nice amount of times. It goes in 3 times, so dividing by 14 gets us x equals 3. And there's our first value. So not negative this time, quite nice to sub that back in. So if we sub that back into an equation, let's pick one. Sub x equals 3 into, and you can pick one at random. Let's sub it into equation 1 again. Let's have a look and see what we get. So let's sub that in. So x equals 3, if we sub it into 3x here, 3 lots of 3 is 9. So we get 9 minus y equals 4. Now you can do this logically. You could think, okay, well 9 take away something equals 4. That number has to equal 5, doesn't it? But if we solve it just like normal, let's get rid of this number. So we know the answer is 5, but let's have a look. Let's take away 9 from both sides, and we get minus y, negative y, equals negative 5, 4 take away 9. And then therefore positive y has to equal positive 5, or we could divide both sides by negative 1 or times both sides by negative 1. But ultimately there we are going to get the opposite value. If negative y equals negative 5, then positive y equals positive 5. Okay, which we knew logically from the start here. When if you look at that, you've got 9 take away 5 has to equal 4, doesn't it? So we've got x is 3 and y equals 5. Okay, so introducing some negatives into our brackets here. So again, it's up to you which two you choose. So there's lots of different ways we could do this. I'm going to go for the two negatives to start with, and then I'm going to times that by the x plus 3. So let's just start with that. Let's go with x minus 4. And again, you can choose either way to do this, and x minus 2. Let's just get the negatives out of the way in the first step. So you might be able to be getting to the point where you can actually do these without writing down all the working out, because you might just be able to spot those middle pieces there. We know we're going to get x squared to start with. We know we're going to get, and if I just write it on here so I can just leave a little bit less working out, we know we're going to do the minus 2x, we know we're going to do the minus 4x, and together they're going to make minus 6x. So we can just tidy that up straight away, minus 6x. And then we know we're going to get negative 4 times negative 2, which is positive 8. When you've got a longer question like this, if you are at the point where you can start to do these quadratics without writing all the working out down, that's brilliant. But if not, just write all the working out down for that. So x squared minus 6x plus 8. Now we're going to multiply that by the final bracket. That final bracket there was the x plus 3. So if we write this all out in a single bracket again, what do we have? We have x squared minus 6x plus 8. Put that in a bracket. And then put your x plus 3 afterwards, and we're just going to follow the same process. And again, you could put this bracket, this x plus 3 at the start, it's completely up to you. I might do that on the next one, but let's have a look. So x squared times x gives us x cubed. X squared times the 3 gives us 3x squared. And then let's move on to the one below. So negative 6x times x, just be careful there, is negative 6x squared. And then negative 6x times 3, 6 times 3 is 18, so negative 18x. And now for finishing this off, moving on to that final piece there, the 8. So 8 times x gives us 8x, positive 8x. And then 8 times 3, both positive, so 24 plus 24. And then again, just have a quick look which ones we need to tidy up. Because of the order that I've done it in, they end up sitting next to each other. So we've got the 3x squared minus the 6x squared, and the negative 18x plus the 8x there. So if we tidy all this up, we still have our x cubed at the start. Positive 3x take away 6x leaves us with negative 3x squared. Negative 18x add 8 leaves us with negative 10. Negative 18 add 8, so negative 10x. And then the plus 24 at the end. And there we go, there's another one tidied up. Right, so we've got some square roots introduced in this one. Now when we've got a square root here, everything underneath it is completely locked until we get rid of this square root. Now the opposite, the way to get rid of a square root is just to square both sides. So if we square both sides, we'll get y squared on the left. And squaring the right hand side literally just removes that square root. So nothing's going to change underneath it. We just have 3x plus 4. So once we've done that quite nice and easy, it looks quite similar to some of the others. We're going to minus 4 from both sides. Then we get y squared minus 4 equals 3x. And then finishing it off just like some of the first ones we did, we're going to divide by 3. So divide by 3, and we get y squared minus 4 all over 3 equals x, or we could just write the x equals at the start. So x equals y squared minus 4 over 3. And that's our final answer there. Just remember that when we've got the square root, everything's locked in until we square both sides. Okay, so quite a tricky question here, a little bit different to those. Now, we've got x's on the top and the bottom of that fraction. Now, in order to get rid of this denominator so that we can start unlocking it, I'm going to just imagine that it's in a bracket. So I'm going to put it back into a bracket like we did before, and I'm going to multiply both sides by x plus 5. Almost like the reverse of the last step we did on all these questions. So I'm going to multiply by x plus 5, so we get z brackets x plus 5, timesing it over, equals x plus 3. From there, it's okay, it doesn't look so bad anymore. We just need to expand this bracket, so we get zx plus 5z equals x plus 3. And now we can just go about that process of getting the x's on the same side. So it doesn't really matter which way we move it in this case. Let's minus the x over. So minus x, so zx minus x plus 5z equals 3, positive 3. Now we'll minus this 5z, so minus 5z. Let's see what that gives us. That gives us zx minus x equals 3 minus 5z. Now we can factorise this left-hand side again, so same as all the others, and we get x brackets z minus 1, because it's just 1x there, equals 3 minus 5z. And then again, finishing it off by dividing by that bracket to finish this question, we get x equals 3 minus 5z all over z minus 1. And there is the end of that question. Okay, so a slightly different question here. We've got 8x squared and we've got 4xy, so the introduction of a different letter here. Let's have a look what happens following the same process. So 8 and 4 both divide by 2 and they both divide by 4, so our biggest number there is 4, so we'll stick 4 on the outside, and they both have an x in, so we'll take the x out as well. Now that right piece there also has a y, but we'll have a look at how we make sure that we get that in a sec. So we've got 4x on the outside, they both divide by 4 and they both divide by x. So open up the bracket. To get from 4 to 8 we need a 2, and to make sure we get up to an x squared we're going to need another x in there as well. Copy the symbol plus, and then to make sure we get to 4, so 4xy we're trying to get to, well we've already got 4 on the outside, so that would be 1, so we don't need to write that. We've already got an x on the outside, so we don't need to put an x, but we do need to make sure we get the y there, so I just have to put a y in with that one. And if we expand that, we'll hopefully see that we're definitely going to get this this piece above here that we've got. So 4x times 2x, well 4 times 2 is 8, and x times x is x squared. Copy the symbol. 4x times y is just writing all the letters, 4xy. Brilliant, so it does work. Okay, so introducing some negatives. Same process though. We'll stick 2x in one bracket and x in the other, as we've got a 2x squared. And again, writing down the factors of 10, so 1 and 10, or 2 and 5. Now again, one of them's going to double, so we could have 2 and 10, or we could have 1 and 20. Are we going to be able to make 9 out of either of those? No. 2 and 10 we could make 8, we could make 12, but we can't make 9. And then 1 and 20 we could make 19 or 21, but we can't make 9. So it's not going to be 1 and 10, which means it's going to have to be the 2 and the 5. Got to be a little bit careful here because we've got negative 9 in the middle, so we are trying to make negative 9, but similar process to when we were factorising before. So let's double one of them, so we could have 4 and 5, or we could have 2 and 10. There we go, just doubling one of them. So again, we're trying to make negative 9, so it's going to have to be 4 and 5. We can't make 9 out of 2 and 10, but we can out of 4 and 5. We've just got to figure out, okay, well, which one of these needs to be negative? And actually looking at it, look, we've got a positive 10 at the end, so they're both going to have to be negative. So it's going to have to be negative 4 and negative 5. So I just want to make sure that that number above the negative 4, the 2, goes in the bracket that's going to be doubled. So on the right hand side there we want negative 2, that's going to allow us to get negative 4, and on the left bracket there we'll put the negative 5. And again you can just expand that to just double check, so 2x times x is 2x squared, 2x times negative 2 is negative 4x, negative 5 times x is negative 5x, and then negative 5 times negative 2 gives us the positive 10 at the end there. And tidying that up, look, these two here do make my negative 9. We get 2x squared minus 9x plus 10, and it matches what we were looking for. So you'll have probably noticed we've got a coefficient bigger than 1 on the x squared here. So we've got to take a little bit of a different approach here. I need to factorise this so that I've just got a 1x squared there to start with. Okay, so taking out a factor of 2, we get 2 lots of x squared minus 5x plus 4. Brilliant. Now we've got something that we can actually complete the square for. So if I have a look at just this quadratic in here, that's what I'm going to complete the square for. I'm going to ignore that the 2's there for the moment. So following the same process as before, so just completing the square for this, we get x minus 5 over 2 squared, and then we need to figure out what number is going to go at the end there. So figuring out what number goes at the end, let's have a look. Negative 5 over 2 times negative 5 over 2 would give us 25 over 4. And if we simplify that, what does that become? That's 24, so it's 6 1/4. Now we don't want 6 1/4, we want we want 4 at the end there. And in order to get to 4, we'd have to take away 2 1/4, so minus 2 1/4. There you go, minus 2 1/4. Now we need to reintroduce this 2. So this 2 was there. Now that 2 doesn't just disappear. Actually, this whole thing has to be multiplied by 2. So I'm going to bring that back in, and now we have to multiply that 2 out. So it's the same process. We just have to factorise the 2 out, and now we put the 2 back in. So if we times both of these by 2, we have 2 lots of this bracket, 2 lots of x minus 5 over 2 squared, and 2 lots of this negative 2 1/4, and 2 times negative 2 1/4 is negative 4 1/2, or 4 2/4. There you go, negative 4 1/2. So that's that times that 2 back out. Now we just need to finish this off to find the turning point. So our turning point is still this number here for our x coordinate, so positive 5 over 2. So 5 over 2. And then the y coordinate is still just this one at the end here, so negative 4 1/2. There we go, and there's our coordinates of the turning point. So you've got to have a look at this question here again. Just rewatch it again if you're not sure. So factorise the 2 out in the first step, or whatever it is. Then complete the square just like normal in the second step, but then just reintroduce this 2 back in, and then multiply both things by 2 for your final step. And again, just reading the turning point just like we did before. So a few extra steps there. We've got the fractions involved, so it is a little bit trickier. Okay, so here's our question. By completing the square, state the coordinates of the turning point for the graph of, and then we have y equals 10 minus 4x minus x squared. Now we already know that it's sloping this way. And that turning point, that point right at the top of the curve there, is what we're trying to find. Now, with the process for this is pretty much the same as obviously looking at completing the square normally. So obviously I will link the video in the description for completing the square, so make sure you've checked that one out first, because this is going to be a little bit harder than that one, but the process is pretty much the same. Now what we need to do to start with, and this time it does matter, but we're going to take that factor of minus 1 out, okay, and it is very important that we do actually take that factor out and show that in this one. So this is the expression we're looking at, 10 minus 4x minus x squared. And if we take that factor of minus 1 out inside the brackets, and again I'm going to reorder them, I'm going to put the x squared first, we'll get x squared, that'll be plus 4x, and it'll be minus 10. Now from there, what I'm going to do is I'm going to kind of ignore the fact that that minus 1's there, and I'm just going to complete the square for what's inside the bracket like we would normally. So again, when completing the square, we're going to halve the coefficient of x, so it would be x plus 2 in brackets squared. When we expand that, we get 4 at the end, and we want to get back to minus 10. Remember, minus 10 is in our original one. So to get from 4 to minus 10, it'd be minus 14. So that's that part in the bracket in completed square form. If we expand that out, it would match the one above. But this is where we have to remember that there was a minus 1 there. Now what we have to do is we have to multiply that minus 1 back into our expression. And I'm going to introduce a second set of brackets, because obviously we already have one set of brackets there. I'm going to put the minus 1 back on the outside. Now when we multiply that back in, it's easy enough. We have to multiply this bracket by minus 1. We don't actually have to do that. You can just stick the minus 1 at the start of the bracket. So minus 1 lot of this x plus 2 squared. And then when we multiply the negative 14 at the end by the minus 1, that's easy enough. That just swaps the sign. So that'll be plus 14. So that's that there in completed square form. And just like normal, we get our coordinates from this. So the x coordinate of the turning point is the opposite of the plus 2. And obviously I am going a little bit quicker than I would on the normal completing the square video. So do check that one out first if this is a bit beyond you. So negative 2, and let's put it up by a diagram, negative 2 would be the x coordinate, and the y coordinate is just that number at the end, which is positive 14. So it's negative 2, 14, and that right there is the coordinate of our turning point or maximum point for this particular graph. So there we go, that's what we're going to find. Obviously our final answer for this, the turning point, is minus 2, 14. And following on from this, we could actually draw even a more accurate sketch now of one of these quadratics, because we can factorise and solve it to find the solutions, and we can complete the square in order to find that turning point. Okay, so here we've got a slightly different question. This is the graph of y equals k to the power of x, where k is a positive constant is shown. Find the value of k. Now that word constant just means that it is not necessarily a whole number, it could be a fraction as well. So when we're having a look at this, we just need to figure out how we're going to approach it. Now, so we know it's going to be y equals k to the power of something, and we can always write that down just to remind ourselves of that. Y equals k to the power of x. Now what we're going to do is we're going to try and figure these out. And what we can do is we can pull some coordinates off of our graph. Now we know that with a graph like this it's going to go through 0, 1. This one's slightly different to the ones we were looking at though, because this one is actually sloping downwards. So something is going to be different in terms of our value of k. And that word there where it says constant gives us a little bit of a hint. It means it's not necessarily going to be a whole number, so maybe k is going to be a fraction this time. And hopefully once we've seen this, we'll recognise that these downward sloping exponential graphs do have a different value in place of k there. Now in terms of how we go about this, we could pick the coordinate 0, 1. Let's just have a look at that one and how we'd approach it. Now we know that 0 is the x coordinate and y is has got a value of 1. But if we were to plug this into our formula, we would have 1 as our y value is equal to k to the power of 0. And that leaves it a bit open-ended because we know that no matter what goes in place of that k, we're always going to get the value of 1. So that's not particularly any help to us. So we're going to have to go for a different coordinate. Let's find a different one. Now there's a couple that I can see here, both in the negative region. I think it's a bit difficult to find a good one in the positive region there as they're a bit small. But if we have a look, where does negative 1 land? Negative 1 lands at 2. So we've got a coordinate there. What about negative 2? That lands at 4. Maybe negative 3. That lands up here at 8. So we could pick any of those. I'm going to go for the negative 1 being at 2. So what we have is 2 as our y coordinate, so 2 is equal to k to the power of our x coordinate there, which is negative 1. And again, here is where you have to have a really good understanding of your, well, I want to say fractional and negative indices, but in this case it's just negative indices. So again, I'll link that in the description, but this is almost a reverse negative indice. So we have to figure out what value to the power of negative 1 gives us a value of 2. And essentially we just have to reverse that power. We know that a negative power does the reciprocal. Now at the moment, 2 is 2 over 1 if we were to write that as a fraction. It always looks a bit weird writing it as 2 over 1, but it just helps to visualise that reciprocal. So if we flip that over, that becomes a half. And obviously it's a power of negative 1 there, so that means there were no powers involved, so a half is equal to k, or k is equal to a half. Now that's our value there. Let's have a look at maybe if we'd pick the negative 2, how we'd approach that, because we might not have a nice value on the negative 1. Now if it was the negative 2, which goes up to a value of 4, this one here we're looking at now, then I would, instead of putting these values in, so I'd have 4 is equal to k to the power of negative 2. And again, we can take the same approach. We know that 4 is 4 over 1. There was a reciprocal involved, so if we flip that over, we get a quarter, which is going to be equal to not k to the minus 2, but just the k squared now. Now we've reversed that negative power. And in order to get rid of the k squared, we would now need to square root both sides. So we would have to do the square root of both numbers there, and we would get 1 over 2, which is equal to k. And there we go, we found that value of k. K is equal to a half. So this is really just highlighting a different technique that we might have to use with some of these harder questions, where we might just have to pull a coordinate off the graph and sub it into that equation. Okay, so very similar question. It says, given that f of x equals 2x plus 5 and g of x equals x squared minus 5, find the value of fg3. So letters round the other way this time, and that means what is f when g is 3, or once g is 3. So the first thing I'm going to have to work out is subbing 3 into g, otherwise I'm not going to be able to put the answer into f. So what is f when or once g is 3? So sub 3 into g, we get g3 is going to equal 3 squared x squared, this one up here, take away 5. There you go. So 3 squared is 9, take away 5 gives us the answer 4. So 4 is what I can now put into f. So now I can work out f4, and subbing that into f, which is up here, we get 2 lots of 4, which is 8, plus 5, and 8 plus 5 equals 13. Okay, so you just got to read the fg or the gf in the order and speak it as it says it. So f of g3 means the function of g, the function of f when g is 3. Okay, so this question here says, given that f of x is x squared plus 4 and g of x is 2x plus 1, write down an expression for fgx. Okay, so we're not putting a number in this time, it says write down an expression for fgx. So that means what is the function of f when you put g into it? Okay, so not any numbers or anything, just what is f when you put when you sub the function g in. So if I want to sub the function g into f, there's a nice little trick for it. I'm just going to put a bracket around the whole function. I'm going to put it in the place of the x in f. So if I actually do that, let's actually put that in there. If I just put the bracket in, so 2x plus 1, it's x squared, so that bracket is squared plus 4. Now that is actually an expression there for f g x, that's absolutely fine, f g x, but normally we would go and expand this and tidy it all up. So obviously if I do want to do that now to tidy it all up, we've got a double bracket to expand there, so we have 2x plus 1, 2x plus 1, and at the end of all that we need to add 4 to the end. So expand that as a double bracket, 2x times 2x is 4x squared. That's that one. Then we've got 2x times 1 and 1 times 2x, and that's going to give us a 2x and a 2x, which makes 4x. And the final multiplication there, 1 times 1 gives us 1, and we're going to add 4 at the end. So tidying this all up, getting that nice expression there, we've got 4x squared plus 4x, and then 1 plus 4 gives us plus 5 at the end. So 4x squared plus 4x plus 5. Okay, so find the 50th term in the sequence. So again, let's find the nth term. So it goes up in 6's, so that's going to be 6n. And then we need to just go backwards, applying that little trick, so minus 6, and we get minus 4. So our nth term is 6n minus 4. Now again, we're trying to find the 50th term, so we're just going to sub 50 in place of the n, and we get 6 lots of 50. 6 lots of 50, take away 4. 6 times 50 is 300, and 300 take away 4 leaves us with 296 as our 50th term in the sequence. Find the nth term expression for the sequence, and we've got 4, 20, 100 and 500. Now when it comes to a geometric sequence or geometric progression, what we need to have a look at is what we are multiplying each term by to get to the next one. And there's quite a simple way of doing that. You just take the bigger term and divide it by the smaller term before it. So what I mean by that is obviously looking at these first two here. If we do 20 divided by 4, that gives us the answer 5, so that means we must be multiplying by 5 each time. Although, as with any sequence, always just double check and make sure. So that is being times by 5, and then for the next one as well, 20 to 100, that is also being times by 5. So there we go, we've figured out what we're multiplying by each time. Now writing an nth term for this is a little bit different to normal nth terms. It's very different to linear nth terms, and it's very different as well to quadratic nth terms. Now I like to link this back to something that hopefully you already know about, and that's compound interest. Now if you take this as an example, if we have £1,000 in the bank, okay, and we're getting a 3% rate of compound interest, and again hopefully you're okay with compound interest. If not, then obviously have a look at that in my percentages playlist. But when we're multiplying for compound interest, if I was to get 3%, okay, I would multiply by, for the next year, 1.03, okay, and in the next year I would have £1,030. Don't mean to write a zero there, £1,030. And then again for the next year we'd do the same, and we'd multiply by 1.03 again. And if I just work that out on my calculator, I get, let's have a look, £1,060 and 90p. There we go, £1,060 and 90p. And that right there is a geometric progression in itself. Okay, we're starting off with 1,000, we multiply it by 1.03 each time to get each next number in the sequence, and again we can then go about creating the sequence. Now in terms of how we go about doing the compound interest, and again hopefully you are well versed with the compound interest, but I would get the starting amount, which in this case is the £1,000, okay, and we would write this down in the calculator. I'd write in 1,000, and I'd write down times 1.03, and we put that to the power of whatever year we're on. Now what I mean by that in terms of whatever year we're on, obviously in the second year, obviously this is our first year here where we start with 1,000, at the end of the second year we would have times that by 1.03 to the power of 1, okay, to get to that second year. When we get to the third year, okay, or the end of that period of time, which is actually the end of the second year, start of the third year, it would have been times 1.03 to the power of 2, okay? So just thinking about what we would do there, to get the start of the third year, I would have done 1,000 times 1.03, but only to the power of 2. Okay, obviously gives me the amount at the end of the second year, which is at the start of the third year. And this concept, this idea, is how we apply this to the actual nth term for the geometric sequence, okay? We take our starting number, which in this case is 4. Let's just do this to the side. 4. I write what I'm timesing it by, just like with compound interest we times it by 1.03. In this circumstance we're timesing by 5. And then I need to write my n number in terms of a power, in terms of the amount of years, like below. So I would write 4 times 5 to the power of n, but if you notice again, the second year the power was 1, the third year the power was 2. It's always 1 less than the actual position it has in the sequence, so it's n minus 1. So I start with 4, I times it by 5, and do that to the power of n minus 1. And if you have a look at my little sequence just up here, 4 times 5 to the power of, and look for the second number there, which is 20. 4 times, let's just write this in fact we'll test it out, let's have a look. So for the first one there, we've done 4 times 5 to the power of 2 minus 1, okay, for the second one. And that is 4 times 5 to the power of 1, which is 4 times 5, which gives us 20. The next one, the 100, we could have done 4 times 5 to the power of 3 minus 1. There you go, for that third number in the sequence. And that would be 4 times 5 squared. And 4 times 5 squared, well 5 squared is 25. 4 times 25 is 100. So there you go, you can see that it works, okay? But really, all we've got to do, we get the starting number, just like we do in compound interest, our £1,000, in this case our 4. You multiply it by whatever the actual term is being multiplied by each time, which is called our common difference or our common ratio there. We're timesing it by 5, so put times 5, and then you just put to the power of n minus 1, and it's always the power of n minus 1 there. Right, okay, so solve these simultaneous equations. Now, a little bit tricky here because we just have a 3x rather than an x there. Obviously, I have two ways of rearranging this. We can make it x equals or we can make it y equals. Now, you should hopefully see which one I'm going to use and why. But if we make it y equals, let's have a look. We'd get y equals, I'd have to add y to the other side. So I would get 3x plus y equals 2. And then subtract 3x from both sides, we'll get y equals 2 minus 3x. That is one option. Now that is the option I'm going to use, but it might be on a quite a tough question that you have to actually rearrange it in a slightly different way if there was a coefficient of y there. And if I wanted to make it x equals, so if I wanted to make it x equals, I can do it in one step, but it doesn't look very nice. I have x equals 2 minus y all over 3, because I've got to divide by 3. So I've got two options there. Obviously that second one isn't going to be very nice, substituting a fraction in, but it can be done, it's absolutely fine to do. Okay, and I will actually have a look at some where you have to work like this on another video, but for the moment let's just stick with those other ones there. So we've got y equals 2 minus 3x, okay, but just so you know, you can actually do it like that as well, but let's get rid of that. So we've got y equals 2 minus 3x. So that's what I'm going to substitute in. Again, remembering obviously we can stick a bracket around that, and we're going to put it in place of y. So if I stick that into the equation there, we have x squared plus 2 minus 3x, that's all squared, and that equals 20. So again, we just need to expand this and tidy it all up. So we get x squared. I probably would take a bit more time expanding this bracket here, so let's do that to the side. We've got 2 minus 3x and another 2 minus 3x. Okay, so 2 times 2 is 4. 2 times negative 3x is negative 6x. Negative 3x times 2 gives us another negative 6x. And then negative 3x times a negative 3x gives us positive 9x squared. So there's all our pieces. If we tidy that up, we get 4 minus 12x plus 9x squared. And we can put that in place now. Now what I'm going to do is I'm going to write that 9x squared first, just to keep it next to my x squared, so I don't forget to simplify them. So I've got x squared plus 9x squared minus the 12x, just keeping it in my normal quadratic order. And that's a positive 4, so plus 4. And that equals 20. So I've decided just to write that in a different way. I just prefer seeing it like that, so it's absolutely fine as long as we keep the symbols correct in front of those numbers. So tidying up these the 9x squared and the normal x squared, we've got 10x squared minus 12x, and then I'm also going to subtract 20 from both sides here. So plus 4, take away the 20, gives us negative 16. Again, I've done that in 2 steps there from that first question that we looked at. Again though, this is quite nice, they're all even, it simplifies, but it's not going to get us down to a single x squared at the start there. But if we divide by 2, we get 5x squared minus 6x minus 8 equals 0. That's fine, we can factorise this, but we've just got to remember here, if we've got a 5x squared, one of our brackets is going to be a 5x. So we've got a 5x and a 1x. There you go. Obviously I've got a video on factorising harder quadratics, so you can always have a look at that if you're not sure on these ones. But we've got 1 and 8 and 2 and 4, and we're trying to make 6 in the middle, and one of these numbers is going to get multiplied by 5. So we could have 5 and 8 for the 1 and 8. You can't make -6 out of 5 and 8. Or we could times the 8 by 5, and that would make 40 and 1. We're definitely not going to make -6 with that. So let's have a look at the other one. 2 and 4. Timesing 2 by 5 would give us 10. So 10 and 4 we can definitely make 6 out of. So we know we want the 2 to double to make 10. We want the 4 to stay as it is. And we want to make -6. So I want +4, take away the 10. And there we go, there's our factorised quadratic there. So we've got 2 solutions. Now this one's nice and easy, x equals 2. And you just got to remember how to work with this one here. So with 5x plus 4, you get 5x equals -4, or x equals -4/5. Okay, you always just flip the sign and divide by that coefficient of x there. Okay, but let's have a look. There are 2 values then. So we've not got the nicest substitution now. Our x equals 2 one's okay. Don't forget we've got this equation up here that says y equals 2 take away 3x. So for the first one, for x equals 2, and this one's our easy one, we get y equals 2 take away 3 lots of 2, or 6. So 2 take away 6 is -4, so y equals -4. And that's our nice solution, that's the one there. And then we'll have a look at finding our other one. And this one is a little bit harder. So our second solution, because we've got to substitute -4/5 in. So we've got when x equals -4/5. Obviously it's a lot nicer if you have a calculator, but if you had a calculator here we could have used the quadratic formula, okay, which we're going to be having a look at next. But without a calculator, we're just going to have to look at how we sub that in. So y is going to equal 2 take away 3 lots of -4/5. Okay, right, so what have we got? 2 take away 3 lots of -4/5. You multiply the numerator by 3. Remember 3 is 3 over 1, so times in the top gives you 12, times in the bottom gives you 5. So 2 take away -12/5. Obviously we've got taking away a negative there, so that can just turn into a plus. So let's get rid of that, and let's just write that as a plus. Turn that back into a fraction, there we go. So we've got 2 plus 12/5. That's not too bad for us to do. I'd rather write 12/5 as a mixed number though. So we've got 2, add, 5 goes into 12 twice with a remainder of 2. So 2 add 2 and 2/5. And if we add that together, we get 4 and 2/5. Which you could also write as a decimal, but I'm just going to leave it as a fraction there, 4 and 2/5. All right, there we go. And there's our y value. So putting it all together, obviously you can write your answers out here. We've got when x is 2, y equals -4, which again you can write as a coordinate if you want, but there you go, there's our first solution. When x is 2, y equals -4. And our other one there was when x equals -4/5, y equals 4 and 2/5. There we go, 4 and 2/5. It's obviously a lot trickier question there because that number that we had to substitute in second wasn't very nice. But obviously just thinking about how you rearrange it, it's the same process, just with a few extra little steps there and a few extra little bit of maths that you've got to think about. Okay, so this question says, Frank, Lewis and James share some money in the ratio 2 to 4 to 3. James gets 90, work how much Frank and Lewis receive. So again, we've got 3 in here, but we've got Frank, we've got Lewis, and we've got James, and their ratio is 2 to 4 to 3. Now, it's not saying that they all share 90, it's not saying that one gets £90 more than the other, it is saying specifically that James, who is on the right there, gets £90. So that is £90. Now what you can think, obviously that is 3 parts, that's the number above, so we could just say £90 equals 3 parts, and there we go, take the same approach. Or when it comes to a question like this where it actually gives you the answer, you could just think logically, well, what do we do? What do we times by to get from 3 to 90? Hopefully you can spot there, that is times 30. Now that is just a logical approach to what we're going to do anyway, because obviously if we've got that £90 is 3 parts, to get the value of 1 part like we have on all the others, we're just going to divide by 3, and we'll get the value of 1 part being 30 quid. And that's what we've done as a logical approach anyway, it's just that we're actually writing it down now. So anyway, if we're going to times them all by 30, we can just do that straight from the ratio now. Up here, we could just say, all right, well, we just need to times all of these by 30. So times that by 30, that would give us 60 for Frank. And timesing this one in the middle by 30 as well. 4 times 30 is 120, and that will give us 120 for Lewis. There we go. And that's all that their values there. Obviously we can write that all down to the side. 2 times 30 is 60, 4 times 30 is 120, and 3 times the 30 is 90, but we already had that. There we go. So obviously we've answered how much they both got. Frank gets 60, Lewis gets 120. And again, we could be asked how much they all share together. So you could do 60 plus 120 plus 90, and that would give us the total there, which is 270 between all three of them. So it just depends on what the question's asking, but there's just a couple of things to be thinking about. Obviously you just need to have a look at the words, allocate the amount of parts to the amount of number that you're given, whether that be all of them, whether it be one of them, or whether it be a difference between them. Okay, so Frank invests £8,000 for 3 years in a savings account. He's paid 2.4% compound interest in the first year and 0.5% compound interest per annum for each year after. And that word per annum again just means per year. How much did Frank have in his savings account after 3 years? Now for this one here, we're going to have to take it in 2 steps, because in the first year we get 2.4%. So we can work out how much he gets in the first year, and then we'll have a look at this 0.5% following that. So in the first year, and I'm going to label this, I'm just going to put year 1. So in the first year, he gets 8,000, and we're going to multiply that by the multiply for 2.4%, so 1.024. And we're not going to put any power with that because it's only in the first year. You could put the power of 1. I'm just going to work that out there. So 8,000 times 1.024, no powers involved, and that equals £8,192. So at the start of year 2, which is what we're looking at, year 2, he now has 8,192. Okay, so that's the amount that he's starting with in the second year. Now for the next 2 years, because it does say obviously this is 3 years in total, so we've already done the first year, so we've now got 2 years at 0.5%. So don't forget that's only going to be 2 years and not the 3. He's going to get 0.5%. So we just have to figure out how we're going to write that as a decimal. So 0.5%, well 1.0 is what we always put. There's not even a whole percentage, so it's another 0. And then for that 0.5%, like the 4 above, we've got the 5 at the end there. So you've got to be very careful that you don't accidentally put 1.05 when it's a 0 point something percentage. Okay, we've got 1.00, and then that 5 represents the 0.5%. Now it's 2 years at that rate, so that one there we are going to put a power of 2 to make sure we get the 2 years there, and we'll see what we get. So 8,192 multiplied by 1.005 to the power of 2. And that gives us our result here. So we have £8,274, and to the nearest penny it's 12p. There we go, £8,274, 12p. It doesn't say how much interest does he earn, it says how much does he have. So that's our final answer there, £8,274 and 12p. Okay, so Ava invested £8,000 for 3 years in a savings account. She was paid X% per annum in compound interest, and at the end of 3 years she had £8,589 and 93p. Work out the value of X. So if we take the same approach here, trying to write down what we know, we've got £8,000. We're going to multiply that by X%, which we don't know what it is, so let's just put X in there. It's going to be to the power of 3, and it's going to give us the answer £8,589 and 93p. Now again, we could just guess numbers, remembering it's going to be a 1 point something number, so you could just guess numbers like 1.02 and see what you get. You could just put that in, that'd be 2%. Okay, remembering obviously the percentage is in that 1 point number like we've been doing in the previous questions. But if we actually just type that in, let's see what we get. We get 8,000 times 1.02 to the power of 3, and we get £8,489 and 66p. Now obviously that's not high enough, so we'd have to go higher again, so maybe we could try 1.03. Try 1.03, which would be 3%. So have a look, go back into the calculator and change that. 1.03, we get £8,741 and 81p. So it's somewhere in between 2 and 3%, and it wouldn't take you too long to actually try these out. But obviously that is quite a time-consuming method, just typing in different little decimals there. So you could try 1.025 and then go higher or lower again. But there's actually a simpler way of doing this, and it's just about rearranging this little equation that we've got written here. So if I want to have x cubed on its own, bearing in mind it's 8,000 times x cubed, I could divide both sides by 8,000. So if I divide both sides by 8,000, that'll give me x cubed on its own. So divide both sides by 8,000. and we get x cubed equals, and let's actually go about doing that, 8589.93, and we get 8,000, sorry I've not actually typed the divide in, divided by 8,000, and we get 1 point, let's have a look, let's write this down, x cubed is 1.0737, what else we got, 4125. There you go. So x cubed equaled this number here. Now if I want to find out what x is, I can just do a cube root, because to find out what the what x is there, if x has been cubed, if we do the cube root, that'll tell us what x is. So if I cube root both sides, let's cube root that, and we get x equals, and you have to be able to find your cube root button. Normally it's behind the square root button, so I'm going to press shift and then my square root button, and it brings up my cube root. So obviously just make sure that you can figure out where that is. And then I'm just going to press the answer button, or you could type that number in there. But if I press equals, and let's have a look what we get. We get 1.023999818. There we go. Now, obviously the percentage here that the person's got is not going to be all these little decimals here. Okay, so obviously because the amount of money at this point here with the 93p has been rounded to the nearest penny, which it probably wasn't bang on, okay, that's going to affect this decimal down here. So we're going to have a look at what it is to the nearest few decimal places. So we know that this 2 here represents 2%. So we know we've definitely got 2% there. There we go. After that, it's going to be 2 point something percent. Now, it's not going to be that 3 there, because afterwards it's 999. So it's very, very likely that that 3 was actually just a 4, and it's most likely that that was going to be 2.4%. There we go. Obviously, we don't know exactly, because obviously we don't know what it was rounded to, but it's very, very likely there that it was 2.4%. Okay, so we're just getting it to that nearest little single decimal of a percentage there, 2.4%. So I'd give my final answer there, and I'd say it was 2.4%. There we go. Obviously, you just need to remember that obviously in those previous questions, we found the 2%, we found the 3% by adding it onto the 1, so it was 1.03 up here, or 1.02 in the previous questions. So that 1.023999 is that 2.4% hidden within there. Okay, and that's how we find one of those. Obviously, you could have, at the starting point though, when I typed in these 1.02s, 1.03s, you could have just tested it out. I think if we'd have tried out 1.025, then it would have been just slightly too high. We might have then gone for just 1.024, and you'd have found that would have given you the answer pretty much bang on. So there's two different ways of doing it. This is obviously the rearrangement way. So one, obviously, to make some notes on there, and obviously figuring out how you do your square roots and your cube roots on your calculator, or potentially a fourth root if it was for 4 years or something like that. So in this question here, it says Ollie drove 56 kilometres from Liverpool to Manchester, and then he drove 61 kilometres from Manchester to Sheffield. Ollie's average speed from Liverpool to Manchester was 70 kilometres per hour, and he took 75 minutes to drive from Manchester to Sheffield. Work out Ollie's average speed for his total drive. So the first thing is we've got all this information, so we can start putting that into our table. We've got this one here, a speed, and we've got this time here, which is in minutes, and that's the first time minutes has appeared on one of these questions. But let's have a look at what happens when we just start putting these in. Now, if I go for this journey, let's have a look. We've got L to M, Liverpool to Manchester. Then we've got Manchester to Sheffield. And we've got the overall, or the total journey. There we go. And again, we're looking for a speed, a distance, and a time. And again, I'm going to put down my speed equals distance over time formula triangle. There we go. So if I start to fill in some of these, and let's just put all these grids in to start with, let's see what we've actually got. So we've got 56 kilometres for the first bit, that's a distance, and we've got 61 kilometres for the next one, and we can add those together. 56 plus 61 is 117 for our total distance. So we've got an average speed from L to M of 70, and we've got a time of 75 minutes. I'm going to put that there, 75 minutes. Now, when it comes to this question here, we'll have a look at what we're going to do with that 75 minutes, because that's our little change in this particular question. So we'll come back to that. But to start with, we can actually work out this time here, can't we? So we've got time is distance divided by speed. So we can do 56 divided by 70. And 56 divided by 70 gives me 0.8. Right, there we go. So we've got 0.8 and 75. Now obviously we can add together distances and we can add together times as well, but doing 0.8 plus 75 seems a bit bizarre. 75.8 is not going to be correct there because the 0.8 is in hours and the 75 is in minutes. So before I add these together, I want to make sure that they're in the same units. Now in this particular question, we're obviously working out a speed, and our speed up here in the question look is in kilometres per hour. So we want to have that 75 minutes in hours. So for the first thing that we need to make sure we do is make sure that we get an amount of hours there. So you might know what that is in terms of hours, but if you don't, you can just divide it by 60. So 75 divided by 60 is 1. Let's just type it in just to make sure we get this on the calculator. There we go. We get 1.25, which makes sense because we've got 15 minutes additional on top of that 60, and 15 minutes is 1/4 of an hour. So that's going to be 1.25 hours there. There we are. And now we can actually go about working out that total time. Okay, we can add those two together now and we get 2.05. Okay, so 2.05 hours. So we're looking at this now. Actually, look, we don't even need to work out this speed box here. It doesn't ask for its speed between Manchester and Sheffield. We've now actually got all our pieces that we need to get our speed for this final total part of the journey. So actually, we didn't even need to work out one of those boxes. So we can just go straight ahead and work this one out here. So speed is distance over time. So we have 117 divided by 2.05. Let's see what we get. 2.05. And we get a pretty nasty number here. We get 57.07317. There we go, and there's a recurring decimal above the 0 and above the 7. Now it's more than likely that this type of question here would then say give it to the nearest kilometre per hour, or give it to the nearest decimal place, or something like that. But obviously, just remembering in terms of an exam, if it doesn't say how to round the answer, you don't go about rounding it in any way at all. You would just write that full answer down there, and we would say that there to in kilometres per hour. There we go. Quite an unlikely answer to appear in an exam if it didn't want you to round it, but there we go, it would tell us in an exam how to round that particular question. Okay, so when looking at population density, we can think about a formula for this. So to work out the population density, which I'll write as PD, you would actually do the population, so the amount of people, population, and you would divide that by the area. Okay, so that is what we would do to work out the population density. Let's just write that P there. So in order to go about finding the population, we could think about rearranging this formula, but we can just apply a logical approach. It says the area of this country is 5,000 kilometres squared. And it said the population density is 315 people per kilometre squared. So in every one of those kilometre squareds, there are 315 people. So it seems quite logical that if we have 5,000 kilometres squared, that we would just do 5,000 multiplied by the 315 people that are in every one of those. Now we can work that out on a calculator, and it comes out as 1,575,000 as our population. So we could put people there, but that is 1,575,000 people. Now that makes sense with our formula as well, because if we were going to rearrange this formula to get population, we would want to times both sides by area in order to remove that divide there in our fraction. So that would mean we had to have the population density multiplied by the area would be equal to the population. Okay, but you can apply a logical approach here because it makes sense for us to multiply when every one of those kilometre squareds had 315 people. It says Ben is going to cover the floor with wooden floorboards, and it gives us a diagram of the floor. It says one pack of floorboards will cover 2.25 metres squared. How many packs of floorboards does Ben need? So the first thing that we actually want to work out here is the area of this compound shape. And there are two different ways of doing that. So as you can see, it's this kind of L shape at the moment, and it's made up of two rectangles. So we have to split this up into individual rectangles so we can work out their areas. So you have two ways of going about that. You could go across and you could split it up into rectangles that way, or you could go upwards and you could split it into two rectangles that way. Of course you could do both and you could split it into three rectangles, but that's probably going to make a little bit more work for yourself. So let's just go with splitting it across and working out the area of these two. So for the bottom rectangle there, you have a length and a width of 3 and 2. So that's going to give us an area of 6 meters squared. Again, just doing 2 times 3. For the top one, you have a length and a width of 4.5 and 2. So if we do 2 times 4.5, that is going to give us an area there of 9 meters squared. So overall, we can work out the actual total area. And 9 and 6 is going to give us a total area of 15 meters squared. Again, just showing you're working out and how you've added them together. So the area of the floor is 15 meters squared. And it said in the question that one pack of floorboards will cover 2.25 meters squared. So in order to work out how many packs that we need to buy, we have to do 15 and divide it by the 2.25. So if you have a calculator, you can just type in 15 divided by 2.25, but if not, you are going to have to just count up in 2.25s. So what you could do is just start making a list. You could do 2.25 plus another 2.25, which would be 4.5, and you could build your way up. But if we do this on a calculator while we're practicing, you'll see that you get the answer 6.6 recurring. Now obviously, we can't go into a shop and buy 6.6 recurring packs. So when it comes to a question like this, we have to actually round that up. The reason that we have to round it up is obviously if we were to buy 6 packs, then we wouldn't have enough. And if we were doing this in real life, we would have to just buy more packs than needed, and we would have some spare left over at the end. So when we get this scenario, we will round that up and we would say 7 packs, and that would be the final answer for this question. Obviously the question could go a little bit further. It could tell you the cost of each pack and potentially ask you to work out the total cost of buying them. So you have to remember to round it up, because in real life, again, we would have to buy the additional pack there, which would give us some left over, but that would be absolutely fine. So this one here says that B, C and D are points on the circumference of a circle. It says ABO is a straight line, so that's this one here, connecting from BA to the centre. So that's a straight line. It says AD is a tangent, so this line here that's forming the base of that triangle is a tangent, and we know from the last question what a tangent forms with the radius. It says angle DAO is 40 degrees, which is labelled for us on the diagram, and it wants us to work out the size of angle BCD. And B to C to D is this one here on this little shape. So let's have a look at this one. Now we already know that there's a tangent meeting a radius, so straight away we should put this 90 degrees in. Okay, it does say give a reason for each stage you're working. So for this one here, we're going to say that that is 90 degrees. And I'm not going to write down all the description here, but you need to say that a tangent meets a radius at 90 degrees, or it forms a right angle, or any variation of that language that you've learnt. Now we need to have a look at where we can go from here. Now we've obviously got this big triangle here, and now we know that that bottom angle there is 90. We are only missing one angle in that triangle, and that angle is just here. So we can work that angle out. So if we do 90 plus that 40 there, that's 130. So to work out the size of that missing angle, we'll do 180, take away 130, and that leaves us with 50 degrees. So we can put 50 degrees there at that central point, and that is the final angle in that triangle. So now where do we go from here? Now we've got a quadrilateral inside the triangle, sort of inside the circle there. In fact, let's highlight it. So we've got this shape here, which is a 4-sided shape. So that is a quadrilateral. Now we know that that's going to add up to 360, but we don't know what the angle is up here. There we go. And there's not really any way for us to work that out. We know that there's 90, obviously in the bottom right of the triangle, but that's not within the quadrilateral there. So we need to take a different approach to this. Now what we do have is we have this angle at the centre being made. Let's get rid of that. And then we've got this angle here that we're looking for, which is an angle at the circumference. But we've got to be very careful here, because although it is an angle at the circumference, it's not related directly to that 50 degrees. Now if we draw these lines in here, there we go, and we can see that that forms that sort of arrowhead shape, and that is where the angles at the centre, angles at the circumference are related to that 50. So this angle here would be half of that 50, it'd be 25. Now in terms of looking at this sort of reverse option here, and this is why this question is what I would say is more of a difficult question, we actually have to look at the angle on this side. Okay, this is the angle at the centre, the big reflex angle. That's what's related to that angle at the circumference that we're looking for. So if we find this angle here, and we would do that by taking away that 50 from 360, that would leave us with 310. So this angle here is 310. And again, you give your reason for that. So we would say the reason being that angles at the centre or round a point add up to 360 degrees. Now we can use that to find this angle here, because now we've got an angle at the centre, an angle at the circumference that are related, and it's going to be half of that 310. So for our working, we'd do 310 divided by 2, and it leaves us with our answer, which is 155 degrees. And it's very important that we give the reason for that. So we would say angles at the centre are double the angle at the circumference, or angles at the circumference are half of the angle made at the centre via the same 2 points or via the same arc. Okay, so there we go. That would be our question there. This question does involve writing down those reasons though, so just make sure that your reasons are nice and logically placed next to your working. And in fact, a good tip that I would suggest for the exam is obviously just to make sure that you label it in sort of points over here. So point number 1, we got the 90 degrees, and I would put my reason, which would be the tangent, and again fully explaining that reason. Then maybe I would do the point number 2, which was the 50 degrees, and again labeling what these angles are. So that was angle, the 50 degrees is angle DOB, or however you want to label it, and just making sure that your description there is as thorough as possible so that it's not lost in your working out. So it says 2 ships leave a lighthouse L, and that lighthouse obviously shown to us on the diagram just here, we've got L. Then it says ship A is on a bearing of 70 degrees from L. Okay, so ship A has obviously gone in this direction over here. There we go, and we've got that 5 kilometre distance there. And then it says, and let's just highlight that, so ship A, and then we've also got ship B, and it's on a bearing of 210 degrees from L, and that's going down here, this 3 kilometres there, down to B. And it says calculate the distance between ship A, and let's just highlight that ship B there with the colour I've just done. It says calculate the distance between ship A and ship B and give your answer to 3 significant figures. So it wants the length of this line here, A to B. Now thinking about how we could actually find that, because we have got a triangle there in that image. Okay, and what we need in order to find that third length there is we're going to be thinking about using sine or cosine. But actually, if we can find one angle, which hopefully you can see is quite a clear one here if you clued upon your cosine rule, if we can find this angle here, we can apply the cosine rule. So that's the angle that we're looking for, and we're going to think about how we could actually get that angle there. So let's get rid of some of this stuff that I've drawn on there. There we go. So it says that this angle here is 70 degrees. Okay, that's given to us in that first piece of information where it says ship A is on a bearing of 70. Then it says ship B is on a bearing of 210. So if I do that in a different colour, that's going right from that north line all the way round to this line here, and it says that that is 210. So the difference between those is going to give us that angle there within the triangle. Okay, the difference between them is going to give us this angle here. If the full angle is 210 and that part of that angle there is 70, then what's going to be the difference between them? Well, let's work that out. It's 210, take away 70. I'm going to do all this on the calculator. This is going to be a calculator topic, so obviously don't rely on it on a calculator question. We should be able to work out that that's 140 really without a calculator. But there we go, we've got 140 degrees within the triangle. Okay, it's obviously just finding the gap between those two angles there. So let's get rid of that and let's stick this angle in there that we're actually going to use. We're going to use 140 degrees. Now once you've got that angle, to be honest, the rest of this question is quite simple, just in the sense that all we really need to do is just apply a bit of cosine rule. And if you're quite clued up on the cosine rule, you're probably already spotting how simple that question is. Obviously, if you find the cosine rule simple, obviously that is already quite a high level topic as well. But we have got the angle and we're looking for this opposite side. So that'll be our big A, this will be our little a, and these will be B's and C's. Again, don't worry about the fact that they've labelled the corners of the vertices of the triangle with A's and B's. When it comes to using the cosine rule, you label it as you want. So using the cosine rule, and thinking about what that is again, we've got A squared equals B squared plus C squared minus 2BC cos A. There we go. Obviously the variation of it that I'm going to be using. So let's just plug the numbers in, that's all we need to do. So we've got A squared equals, we've got, let's just write this down, B squared is 5, so 5 squared plus 3 squared minus 2 times 5 times 3 cos 140. There we go, we'll put that 140 in a bracket, that's what comes up on the calculator. So let's just type that all in and that'll give us our value of A squared. So if we type that in, 5 squared plus 3 squared minus 2 times 5 times 3 cos 140, let's just double check that, make sure you've typed it in okay. So 5 squared plus 3 squared minus 2 times 5 times 3 cos 140, lovely, press equals. There we go, and we get a squared equals 56.981. And a few more decimals. We're not going to write them all down because we obviously want the value of a, so we're going to have to square root that anyway. So to square root that then, let's just write that working out down. We're going to do the square root of that, and we get square root answer 7.548. Let's just write all this in. 7.548. How many decimal places or significant figures does it want it to? Let's have a look in the question. So it gives your answer to 3 significant figures. So I've written down 4 significant figures at the moment, so that's plenty for my working out. There we go. So all we need to do now is chop that after the 3rd significant figure, which is after the 4, and we get our value here of 7.55. There we go. So let's write that down over here. We've got 7.55. Context of the question, it's in kilometres, so 7.55 kilometres. Right, there we go, and let's just highlight that. There we go, as our final answer. So just thinking about how we used a bit of bearings there to find the missing angle, and then we just applied a bit of cosine rule, obviously, to find our missing length there. So this question here says, calculate the length of DC. Now there's 2 triangles here put together. We've got a triangle on the left there, ABD, and we've got a triangle on the right there, that right angle triangle, BDC. Now obviously, if we've got a right angle triangle involved, we could have to use some Pythagoras or some SOHCAHTOA in this question, but we'll just have a look and see what we can find. So we're trying to find the length of DC, which is this length just here. Now at the moment we've not got enough information to sort of move around the triangle. The right one there we've only got an angle, no lengths, and the left one there we've actually only got one angle and one length, so we're going to have a look and see if we can find anything else. Now straight away we can work out this angle just here, because that's on a straight line with the 54. So if I do 180 take away 54, that gives me the angle 126. There we go, so 126 degrees. Now we still don't have enough information to use the sine rule because we haven't even got one pair of opposites yet. So actually we're going to have to look at finding something else. Now again, we've got angles in a triangle, so we can find this one just up here. So 28 plus 126 adds up to 154, and if we take away 180, take that away from 180, we get 26 up for this angle just here. I'm just showing my working out for that. I did 180, take away 154. There we go, 26. Now let's have a look. Do we have a pair of opposites? So opposite the 25, we've got that 26 degrees. Okay, so if we're going to try and find this side here, we just need to have a look for a pair of opposites now to see if we can start moving into that triangle on the right. So opposite the 25, we've got that 26. So let's call 26 big A and the little 25 little a. And then obviously another pair of opposites we're looking at is the one where the 28 is, so big B, and the side we're going to find here, little b. So we're trying to find a side length, not an angle. So we're going to use obviously the first formula we were looking at, which was a over sine a. So little a is 25. So a over sine 26, that angle up in the top that we've worked out, has to be equal to x, the length that we're looking for. Obviously not the length in the final that I've labelled on the right, but the question mark there. So x over sine 28. There we go, and let's rearrange that to get our value of x there. So 25 sine 28 over sine 26. That's quite nice, that's going to give us our answer straight away. So 25 sine 28 all over sine 26. Press equals, and I get the value 26.77. and a few more decimals. It doesn't say how to round it in this question, so I'm just going to round it appropriately. We're just having a look at actually how to approach this question, but we've got 26.77 for this length just here, and I'm going to leave the answer on my calculator, so 26.77. Now looking at that triangle on the right now, it's a right angled triangle. We've not got enough lengths to think about using Pythagoras, so we're going to have to think about another way. So we're going to have to look at using some SOHCAHTOA here. So obviously thinking about SOHCAHTOA as well. So opposite the 54 is the side we're looking for, so that's our opposite side, and we've just worked out the hypotenuse of that triangle. So O and H is in our sine formula, thinking obviously about your SOHCAHTOA as well here. So we're trying to find a side length, we're trying to find the opposite, so we're going to times S times H. So we're going to do H, which is 26.77, multiplied by sine 54, There we go, using a bit of SOHCAHTOA, and let's type that in. I've already got the answer for the 26.77, so I'm just going to times that straight away by sine 54, and it gives me the answer 21.66. I'm going to keep it to 2 decimal places, and it is all about meters. There we go, so 21.66 meters, and there's the final answer to that question. Obviously just rounding it however we would be asked to in a particular question. So something a little bit different there, thinking about obviously your Pythagoras or SOHCAHTOA and whether that might be involved in a question, but also thinking on the left there about some missing angles in the triangle or on a straight line to actually get those angles that you need so that you can get your pair of opposites. Now it says here, work out the volume of the cylinder and give your answer to 3 significant figures. Now, as I mentioned, we're going to be using the same principle as before. Okay, so we're going to look at the cross-sectional area, which in this case is the circle sitting on top. So in order to work out the area of a circle, we need to make sure we know the formula for the area of a circle. And the formula for the area of a circle is area equals pi r squared, where r is the radius. Now this question has given us the radius. Sometimes a question might give you the diameter. It might have said that the full length across was 22, and in which case we would need to halve it in order to achieve or get the radius there. So to work out the area here, we're going to do pi and multiply that by the number we've been given, which is 11 squared. There we go. Now depending on which calculator you've got, that might give you the answer 121 pi, so you're going to need to turn that into a decimal, but again you might not have a calculator that actually shows that functionality. It is quite a handy function if you have got one, and it is worth investing into a Casio calculator. Again, I'll put some links in the description if you want to check some out. But there we go, there's our answer, 121 pi. And I'm going to write the answer as a decimal just in case anyone is using this and doesn't have a calculator that shows your answer like that. And ultimately we've got to give our answer to 3 significant figures anyway. So that answer there comes out as 380.1327111, and that is the area of the cross-sectional area up there, which is a circle. Now in order to work out the volume, just like we did on 3D prisms when we were looking at the volume of a prism, we are going to multiply it by how far that face goes through the shape, in this case that is the height of the cylinder, so that's going to be 30 centimeters. So we take the area, multiply it by the height, which is 30, and we're going to get a final answer there. So if we multiply that by 30 on the calculator, again we get an answer in terms of pi, but if we just write down the decimal version, we get 11,403.98133. So there is our volume. Obviously that's going to be in centimetre cubed, so we won't forget that when we write our final answer, but we need to round this to 3 significant figures as we've been asked in the question here. And we're going to be looking at 3 significant figures throughout all of these questions. So in order to round that to 3 significant figures, we're going to go from the first whole number 3 along, so 114, chop it after the 4. And in this case, the number that we've chopped after is in the hundreds position. So actually we're going to be rounding this to the nearest 100. So 3 significant figures in this case will be the nearest 100. So that's going to be, as a final answer, 11,400 centimetres cubed. And there is our final answer for the volume of a cylinder. Okay, so hopefully nice and easy. It links in very nicely with the volume of prisms in the video that I mentioned before. We're just going to work out the area of the cross section, which again in this case is a circle, and then times that by the height. Okay, so the surface area of a cylinder just requires a little bit more working out. Obviously we're looking at area, so it's going to be a little bit different anyway, but we have just got a little bit more working out when we're working out the surface area as opposed to when we're working out the volume. Now when we're working out the surface area, we're going to work out the total area of all the different surfaces. And you can see we've got a circle on the top, and we've already been working out the area of that, and the one that you can't see that's on the bottom. If I try and highlight that in, you've got a little circle down there as well. So we're going to have to work out the area of those two. Obviously they're both identical, so we only need to focus on the one on the top, and then we can double it up. And then we also have another surface here, and that is the curved surface going around the outside of the cylinder. And we'll talk a little bit more about that in a sec. But if we start with the circles, as we've already been working those out, we should be able to get those done nice and easily. So for the area of the circle, obviously it's pi r squared, so we're going to do pi times the 9.3 squared, and that's going to give us the area of the circle. And if we write that into our calculator, what have we got? 271.716. Now it wants the answer to 3 significant figures, so what I'm going to do is I'm just going to keep my answers to about 3 decimal places, which in this case for these looks like it's going to be about 6 significant figures for this one, but I'm just going to keep it to a much higher degree of accuracy than we want in our final answer. It's a good practice just to write them all down, but I think we'll be absolutely fine keeping it to those 3 decimal places. So we've got 271 point, and we get 716. Now, and there's obviously a few more decimals after that. Now, obviously we're going to double that up as we have 2 of these circles. So if we times that by 2, that's going to give us the total area of those 2 circles. So I'm just going to do times 2 on my calculator straight away, and there we go, we'll write down these. So we have here 543.43, and actually when we double the answer that I had on the calculator, that's going to round up to 433. Okay, so there we go. There is the answer on the calculator. Obviously there's a little bit of difference there. Obviously with the number above, I've not actually doubled that number, I've doubled the one on the calculator. But in fact, let's just write everything down, just to avoid that little bit of confusion there. So we have 4326972. That's the full answer that I've got on my calculator. So that is the total surface area of the 2 circles. Now we need to have a look at, as we mentioned, the curved surface around the outside. Now if you imagine that if this was like a hollow cylinder, and we took a pair of scissors and we cut down the centre just here, and we unravelled the cylinder and flattened it out, what we would actually have is a rectangle. Okay, so we would have a rectangle, it would have a length here of 12.4, the height of the cylinder, but we would need to work out the length going along the top. Okay, this length just here. So in order to get that length there, if we look at our cylinder, that length there is actually the length that's going round the outside of the top there, around the circumference of the circle. So actually that length that we're trying to work out on the top of that rectangle, let's see if we can get rid of that arrow there, is actually just the circumference of the circle. And the formula for circumference is pi times diameter, or pi times 2r, depending on which formula you use, but this one seems to be more recognised, so we'll go with circumference is pi times diameter. Now obviously that means we need to know the diameter of the cylinder here, and we've got 9.3 as the radius, so if we double that we get 18.6 as our diameter. So in order to work out the length along the rectangle there, we can do pi and multiply that by 18.6. Obviously that has a numerical answer, but I'm just going to leave it as pi times 18.6. So to get the area of the rectangle, that's nice and easy, it's just length times width. So if the length is pi times 18.6 and the width is 12.4, if we multiply those all together, let's see what we get. Pi times 18.6 times 12.4, and that gives us a final answer of 724.576. And what else have we got? 9296. There we go, just about fit that in. So that is the curved surface area around the outside of the cylinder. Now obviously we need to add these all together to get the total area, so we're going to add these 2 numbers together, and that's going to give us our total surface area. Let's just put a little plus there. Obviously just being careful with this sort of question, we're going to add those up in a sec, but obviously just being careful that that curved surface area there, we're getting the circumference as the length of that rectangle. I think that's the difficulty here, remembering to do that when you've got this type of question. But there we go, that's how we're going to work these out. We just need to finish this off by adding those together. So I'm going to do that inside the cylinder there. So we've got 724.576, the curved, plus the 2 circles, 543.432697. There we go, pressing equals, and we get a final answer here of 1228.009627. And again, 3 significant figures. So let's round that off. 126, the number in front of the line is the nearest 10, so that's going to be 1270, and again it's about area this time, so that's going to be centimetres squared. So there's our final answer, 1270 centimetres squared for our surface area. Okay, so obviously you've got the 2 circles to work out and the curved part using that circumference for the length of the rectangle. We've got the vector A, which is 5 over 3, and the vector B, which is 4 over 2. And it wants us to write down A plus 2B as a column vector. Now the process to actually go about doing this is quite nice and simple, but it's important to understand why we go about the process we do and how it works. So that vector A, 5 and 3. Now the number on the top represents the movement left and right. So a number 5 means a right movement of 5. Okay, if it was -5, that would be going left by 5. Now the number on the bottom represents going up and down. So after it's gone right by 5, it's then going to go up by 3. So there we go, it's going to go up 3 as well. So if we think about this as a start and end point, it's going to start over here where we started, and it's going to end just here at the top of that 3. So the actual vector itself would go from there to there. There we go, and we would put a little arrow on there just to indicate that it's gone in that direction, and that right there would be the vector A. Now we could actually just get rid of these movements now. I'm going to leave them on there, but obviously the actual vector itself is that vector there with the indicated arrow showing the direction that it's gone in. And that's our vector A. And we could do exactly the same for vector B. We're not going to do that because obviously it's just going to be the same. It's going to go right by 4 and up by 2. But essentially what we're being asked to do here is to combine these vectors. So we've got that it wants us to write down A plus 2B, or 1A plus 2B. Now that means it wants us to do the movement A, which is going to go across 5 and up by 3, and then it wants us to do the movement B, and it wants us to do that twice. So we're going to go across by 4, and then across another 4, and then up by 2 and up another 2. So in order to combine all of that, and just to show the total movement that we're doing, we can actually just do it numerically. Okay, we don't have to do these drawings, or it is good to know these drawings for future questions and just obviously being able to understand the question. So the vector 5 over 3, we're just going to write that down, 5 over 3, and that's our vector A. And we're going to add to that 2 lots of B. Now I'm going to put this outside the brackets, so I'm going to do 2 lots of 4 over 2. Now you didn't have to write down 2 lots of that, we could have just straight away times them by 2. So if we write that out as well, we've got 5 over 3. And then we've got 2 lots of the other ones. We've got 8 over 4, just doubling those vectors in there, and that's what we're going to add together. So that's a movement of 5 across and 8 across. So if we just add together those top numbers, in total there, that's a movement across of 13. And on the bottom, we've got 3 and 4, and that's a total movement of 7 going up. So our final vector there is 13 over 7. And it is as simple as that with column vectors. It's just a case of finding the 2 vectors that you can add together and literally just adding those together, the top numbers, and adding together the bottom numbers. Now it says Josh gets the bus to and from school each day, and the probability that his bus is late to school is 0.14, and the probability that his bus is late home is 0.32. Work out the probability that exactly one bus is late. And we'll have a look at that language in a sec, exactly one bus is late. But let's just have a look at constructing our tree here. So we have one option here, and let's think about this as his journey to school. So let's just label that as to school. And it says it's either late or not late, and I'm just going to put not late for that. So the probability that's late is 0.14. So if we take that away from 1, or think about it as a percentage of 100, so that's 14%, and 100% take away the 14% would leave us with 86%, or 0.86. Obviously just take your time with that. These 2 branches here have to add up to 1, so always just double check that they do actually add up. And that's the journey to school. Now obviously 2 separate journeys there, and then we've got to think about the journey home. And again, it mentions that it's either going to be late, so I'll label that late, and not late. And again, I'm just going to quickly draw in the one below as well, because these are going to be replicated. They're going to be the same, the top and the bottom. So it says the probability is late home is 0.32. So we can put that in the late there, and we can put it on the late down here as well. And again, that's 32%, and 100 take away 32% would leave us with 68%, sorry. So that would be 0.68. There we go. And again, just double check that they definitely add up to 1. Now this question said exactly one bus is late. So in this time, late at the top, that's not exactly 1, so we don't want that one. We've got late and then not late, that's exactly 1. We've got not late and late, that's exactly 1. And then we've got 2 here where they're both not late, so that's definitely not exactly 1. So we've got the 2 options there that we want. We've got the ones in the middle, and they're the two that we need to work out here. You've got to be careful with this one because these two in the middle aren't going to be the same like they were in earlier questions. They are actually going to be different probabilities in the middle here, so don't just work out one and double it, always just work out both of them. So going up the late, we go through 0.14 and 0.68. So if we work that one out first, we've got, and let's see if we can do this to the side. So we've got 0.14 multiplied by 0.68, and that gives us a probability there, which I'm going to do on the calculator. 0.14 times 0.68 gives us a probability of 0. That's a bit longer. Let's have a look if we can fit it in. 0.0952. There we go. And that is our first probability, 0.0952. Let's have a look at our second one. So for the second one, obviously we could be not late and then late. And that's going to be, let's see if I can fit this in, 0.86 multiplied by the 0.32 there. And again on the calculator, 0.86 times 0.32 gives us a probability of 0.2752. 0.2752. There we go, and that's the probability of that route. Now obviously just like before, we've got two outcomes here. We've got late and then not late, or not late then late, so we need to add them both together. So if I do that up here, we've got 0.0952, and we need to add to that 0.2752. There we go, and if we add them together, 0.0952, I'm going to do it on the calculator, we get 0.3704. 0.3704, and there we go, there's our final answer combining those two probabilities. Okay, so slightly nastier in terms of the decimals there, but obviously you can see that the process is the same. It's all about just constructing that tree very carefully and making sure that you go through the appropriate routes. Obviously if you're happy to do this without a tree, you can do, but I would advise a lot of people obviously just prefer the visual method here, actually seeing the journey. Okay, so it says here there are 10 pens in a box, there are X red pens in the box, and all other pens are blue. Jack takes at random 2 pens from the box. Find an expression in terms of X for the probability that Jack takes 1 pen of each colour, and give your answer in its simplest form. Now again, with a question like this, we can write our different colours here in a ratio. We can say that in terms of our ratio, we've got red and we've got blue, and for red there, we know it's X. For blue, we don't know at the moment, but we know that the total is 10 pens. So for blue, in order to get the amount of blue, we would take the total, which is 10, and we take away however many that are red, and in this case red is X. So we would do 10 minus X, and that would be our total there for blue. Now that's going to allow us to create our fractions here for our different probabilities. Now different to the last one, because we are looking at 2 separate probabilities here. And when we're doing that, when we're looking about these sort of journeys, it's easy for us to draw a probability tree. Now that being said, you don't have to draw a probability tree for these, but it does sort of make it a little bit more visual and a little bit easier to understand. So let's have a look. We've got red and we've got blue. And on that first pick there, when we take that first counter out, and just something to mention here, although it does say in the words, Jack takes at random 2 pens from the box, the only way that we can work through this problem is to imagine that we first take 1 pen out, assess the probability of that, and then once that pen is removed, we take out a second one. So we're never going to remove 2 at once. We're going to work on the premise that we take 1 pen and then take the second one. So having a look at this then, we've got red, which is X, the probability of red, out of 10. For blue, our expression there for blue is 10 minus X over 10. Again, just taking these probabilities from up here, X out of 10 and 10 minus X out of 10. Now for the second one of our counters now is going to be removed. So if we now take out a red, it's going to be different, and if we take out a blue again, it's going to change this slightly. So let's label this up, red and blue, and this one here will be red and blue. Now as we are looking at the probability of having different colours, so that's what it says, we want the probability of, and let's just highlight it, 1 of each colour, we don't actually need to look at red red or blue blue, but for the purpose of our learning here, we'll have a look at filling in all of these probabilities. So for that first one, if we take a red out, it's going to be X now minus 1, because we're taking 1 of those reds out. And it's no longer going to be out of 10 counters, it's going to be out of 9, pens. So X minus 1 over 9. Okay, so onto our probability for blue. If we take out a red to start with, our numerator there is not going to change, so that is going to stay as 10 minus x, but now that is going to be out of 9 as one of those counters is going to be removed. So there's our two probabilities there for red and blue on our second part of the journey. Let's have a look if we've taken out a blue counter. So if we take out a blue counter, the numerator for red is not going to change, so it's going to be x, and that's going to be out of 9. And if we take out one of those counters for blue, then the numerator is going to reduce by 1, so that would be 9 minus x, and that again would be over 9. Now again, we don't need the full journeys here, we just need to have a look at the two different counters. So if we go up the red route and down the blue route, that's going to be one of our probabilities. So we need to multiply those two fractions together. And likewise, we could go down the blue and then take out a red. So let's take these two probabilities and write those out. So going up the red and then the blue, we have got x over 10, and we need to times that by the 10 minus x over 9. For the other route, for blue and then red, we've got 10 minus x over 10, and we need to times that by x over 9. So these are the two little fractions that we need to work out. So let's get rid of this tree and we're going to figure both of these out. So let's get rid of all of that. There we go. So just looking at these two fractions then. Now the numerator there, we've got x multiplied by the 10 minus x. That's going to be 10x minus x squared on the top, and that is 10 times 9, which is 90 on the bottom. For the second one, we've got 10x again minus x squared, and that is again over 90. Okay, so we end up with the two of the same fractions here. Now let's have a look. We need to add these two together. Just like normal probability trees, we're going to have to combine these together. So let's just write that out as our actual working. So 10x minus x squared over 90. And we're going to add to that the same thing, 10x minus x squared over 90. Now when we add fractions together, our denominator there isn't going to change, so it's still going to be over 90. But we need to combine everything on the top. So we've got two lots of the 10x, so that is 20x, and two lots of the negative x squared, so minus 2x squared, and that is all over 90, and there is our final fraction. It does, however, say here, give your answer in its simplest form, and if we have a look, we can divide the top and the bottom by 2. So if we do that, if we divide everything by 2, we'll have 10x again on the top, minus 1x squared, and we divide everything by 2, and then also 45 on the bottom, dividing that 90 by 2. And there we go, there's our final answer, 10x minus x squared all over 45. Cool, so that's our second question. If any of that was a little bit too quick for you, again, I do have lots of videos on probability, and it's particularly these ones involving algebra, so we'll link those in the description as well. So do make sure you check those out if any of these are a little bit too quick for you. But as I said, these are difficult questions, so they do take a little bit of time. And it says, on an activity day, students play one sport, either football, hockey or tennis, and it said there are 120 students, 30 are boys, 12 of the 38 students who play hockey are boys, 35 of the 45 students who play football are girls, one of the girls is chosen at random, write down the probability to play tennis. So this is very similar to our last one in that we're going to have a very similar table. Okay, we're going to have a nice table drawn out. We've got boys, we've got girls, and we've got a total, which I'm now just going to label as T. Okay, you can write the full words in if you want. And then I've got 3 options and a total at the end. So we've got football, we've got hockey, we've got tennis, and again a total, and then I'm just going to label that as total as I've got another T up there. Right, okay, so putting all the pieces that we've got there are 120 students, so let's put that in our total down there, it's 120 in total. We've got 30 of the students are boys, so in the boys column, total is 30. The next one there, we've got 12. Let's have a look. This has got 2 bits of information here. Look, it says 12 of the 38 students who play hockey are boys. So that says 12 of the people that play hockey are boys, and that's out of the 38 that play hockey. So 12 are boys. Let's have a look for the hockey column. 12 boys out of 38 down there. And we've got the same piece of information here with the football. It says 35 of the 45 who play football are girls. So in the football column, we've got 35 are girls out of the 45. There we go, so that allows us to put 2 bits of information in. So now we can go about actually filling in the rest of this table. So let's have a look then. We've got the first column there, that has to add up to 45, so we're missing 10. So we've got 10 boys. And then going to go across the top here. So at the moment, along these two, we've got 22 so far. We need to get to 30, so that's an extra 8. Let's have a look where we can go now. We can go down this way as well. Okay, we've got 30 boys, so that's going to be 90 girls to make sure it adds up to 120. And where else can we go from here? We've still got this missing box here as well. So at the moment, these two, what do they add up to? We've got 40, 50, 60, 75, 83. That adds up to, we need to get to 120. So that is going to be an extra 37. And then we've also got the one above that now, and obviously these two in the middle. So moving down this way, we've got 12 there. We need to get to 38, so that's an extra 26. And we've got 8 here, we need to get to 37, so that's an extra 29. There we go. And as I said before, just a quick check that these still add up to 90. So 35, add 26 is 61, plus the 9, 70, 80, 90, yes, that all adds up, so that's absolutely fine. Right, there we go, so that's our table filled in. And then let's have a look. It says one of the girls is chosen at random. Okay, so one of the girls is chosen. Write down the probability that they play tennis. Okay, so the language is different here, and this is important. It says one of the girls is chosen. So if we have a look, how many girls are there in total? There are 90. So one of those 90 girls is chosen. So our probability this time is going to be out of 90. Just got to watch out for the language there. What's the probability that they play tennis? Well, there are 29 there that play tennis. So that's going to be 29 out of 90. Okay, so obviously the language is different there. It said one of the girls is chosen, so that specifically, that dictates that you are having to choose from one of the 90 girls, and then out of that 29 of them play tennis. There's our probability. And again, as with all probabilities, you do not have to simplify that. You can just leave it as it is. Again, it's an important piece of information there. It tells us specifically that 29 out of 90 play. Not that that one does simplify, but if it does, you don't have to simplify it. Okay, although you wouldn't be wrong for doing so, but it's just going to waste a little bit of your time. Now for this question, we are actually going to draw the histogram. So again, if you are confident at drawing a histogram, you can always skip forward, and I'll chapter the video for you so you can skip forward to the point where we find the median. But in order to draw the histogram, we need to remember that we have to plot the frequency density. Now this is a particularly nasty one because the frequency density and the scale has not been done for us, so we're going to have to do that ourselves. But that's not particularly difficult here in our formula, and again I am going to assume that you know the frequency density formula on this because you've seen the past video. But in order to work out the frequency density, we do the frequency divided by the class width. Now whenever I do this, I always label the class widths first. So for that first one there of 90 to 100, that has a class width of 10. And you can always feel free just to label that somewhere near your table. And then the next one will have a class width of 5. Then we've got another class width of 5. We've got a class width of 10 and a final class width of 20. Now, of course, a lot of these questions are calculator based, so we are going to be using a calculator here. And the formula that we're going to use is frequency density is equal to the frequency divided by the class width. So again, at this point, if you want to pause the video and have a go at this question, please feel free to do so, but otherwise follow along as this is going to be mainly an instructional video. So for the frequency density, we're going to label it to the side. The frequency is 13, and if we divide that by 10, we get a frequency density of 1.3. For the next one, it's 16. If we do 16 and we divide it by the class width of 5, we get a frequency density of 3.2. On to the next one, we have 18. 18 divided by 5 is going to be 3.6. So that's our next frequency density. We've got 22 divided by 10, which is 2.2. And for the last one, we have 12 divided by 20. And 12 divided by 20 comes out as 0.6. So all we need to do now is we need to draw our histogram. So first things first, we need to plot the scale down the bottom. And you can see that the speed starts at 90, just up there, and it goes up to 140. So we can plot this in maybe in tens. If that was 90, then we could go along, this would be 100, just here. If I can actually get that to put a mark in, make it nice and clear. We'll put this one as 110, 120, 130 here, and 140 right at the end. So there we go, we need to label that up, 90, 100, 110, 120, 130, and 140. Now, of course, whenever it comes to a histogram, you need to label your axes. I'm not going to be able to fit that in underneath, as I've tried to make the graph as big as possible here, so I'm just going to put it to the side, and that is a speed, and we should put that's in kilometers per hour. Now, up the other side, we're going to do frequency density. So before you do that, you just want to identify where your biggest number is. So 3.6 is our biggest frequency density, so we need to probably go up to 4. So if I was to have this as 1, obviously starting down here at 0, that would make this one 2, 3, and 4. So that looks fine. We could probably scale that a little bit bigger, but that is going to be absolutely fine. So 1, 2, 3, 4. Okay, so moving on to the next part, we just need to draw it in. So for the first one, we have a speed that goes from 90 to 100, and that has a frequency density of 1.3. So go along to your 100, scale that up to 1.3, obviously using a ruler and a pencil, and draw in your first bar. For the next bit, we can find the next one, which is 3.2. That has a width of 5. So we go up to 3.2, just past the 3, 2 little squares there, paying attention to the scale, and there's your second bar. The next one's 3.6, that goes up to 110, so we'll go up. 3.6 is just past halfway by 1 square, and there we go as our next one. The next one's 2.2, so I'm just going to obviously use a ruler here, go across, and this has a width of 10, so this goes to 120. I do have to draw that again. So it's 2.2, goes across to there, and then down to 120, and the next one has a width of 20 and only has a frequency density of 0.6, so just above 0.5 there by 1 square, and there we go, that's our histogram drawn. So obviously that's a nice little reminder for you on how to draw a histogram. Of course we need to label our axes over here, we need to label that as the frequency density. There we go, so I'll just put frequency density there, and then we just need to find our median. Now, when it comes to finding a median, you can either do this from the graph or you can do it from the table. Now, personally, I would do it from the table, because if we look at the table, it just collects all our numbers nice and easily. And in order to find the median, we take our normal statistical approach, which is to add up the frequency. And if we add those up, they add up to 80. And when we are finding where the middle number is, you add 1 and divide by 2. So if we add 1 to 80, let's have a look, 80 plus 1 is equal to 81. If we divide that by 2, we get 40.5. Let's actually write the correct number there, 40.5. Now when we're looking at 40.5, that is the 40.5th number. So that's not our median, but that's where our median lies. It's the 40.5th number. And if we go ahead and look at the table, we need to just count down the table and figure out where that is. So to make this a little bit easier, I'm going to get rid of some of our working there. Obviously always leave your working out, but just so you can see this a little bit clearer, we'll get rid of all of this, and then we will just have a look at finding the median. So I've got rid of that to the side because it's just going to be a little bit easier to count. And if we count down the table, at this point we've got up to the 13th. If we add the 16 to that, we're now at the 29th person. And if we add 18 to that, that would get us to 46. So sorry, that's not going to be 46, is it? That's not very good. If we add 18 to that, it gets us to 47. So looking at our table there, the 40.5th person is going to be in that third row there. So it's going to be somewhere in here. And we need to find out where that person is. So in terms of how far into that row, well, if we had 29 on the row before, to get to the 40.5th person, that would be an additional, and let's just think, 40.5 take away 29 would be an additional 11.5 people. So that would be plus 11.5. So we want to find out where that 11.5th person lies, and we can do this as a fraction. So if we get rid of that 47 there, because we don't really need that, we just know that that 40.5th person is going to be there. So what's that going to be as a fraction? Well, we could think about this to the side. So 11.5 people out of the 18, or it might not necessarily be people here because I haven't actually given you the story behind this question, but it's about speed, so let's just assume that it's cars. So this is going to be the 11.5th out of 18 cars. And if we work that out and just type that in on a calculator, let's just see what we get. Probably not going to be a very nice number there, but if I do 11.5 divided by 18, it comes out as 0.638, and we have a recurring dot above the 8. Now that right there is the percentage into that particular portion of that row. So if we were to turn that into a percentage, it'd be 63.8% or 63.8 recurring percent. So we want to work out as a percentage of the width, how far in is that 63.8 recurring percent. Now looking at that particular width, it goes from 105 to 110. So that has a width of 5. So if we want to go 63.8 recurring percent into that, then we can just take that decimal and multiply it by 5. So if we do that, and we'll do this again to the side, and we're running out of space a little bit, so we'll get rid of some of this working out here again. Let's get rid of that. That's how we found the median. So 5, the width, multiplied by 0.638 recurring. Let's just type that in on the calculator. That comes out as 3.194 recurring. So 3.194 recurring. So that is how far into that width of 5 we need to go. And as you can see, there's quite a lot of working out here, which is why this is a high graded topic. But if we have to go 3.194 recurring into that particular class, which starts at 105, then we just need to add that on to 105, and that will be where our median lies. So if we add that on to finish it off, let's just do it over here. So 105 plus 3.194 recurring, we get a final answer of 108.194 recurring. There we go, and that is in kilometres per hour. So that would be our final answer, 108.194. It doesn't say in this question how to round it. It would be appropriate to round it to maybe 108.2 potentially kilometres per hour, but that is absolutely fine to leave your answer in its exact value there, 108.194 recurring. But again, you could round your answer to particular ranges. You could even say 108, and you might get a slightly different answer if you do it from the graph or use a graphical method. But it's much easier to do it from the table there, even though obviously that doesn't look very easy. It is a difficult topic. But just running through what we did, we added up the total frequency, which was 80 people, to find the middle, add 1 and halve it, so 40.5. We counted down the rows to figure out that the 40.5th person laid in the third row, which is the 105 to 110. That went 11.5 into that row, so the 11.5 over 18 gave us our percentage, or our decimal version of the percentage, which is 0.638 recurring. So we found out the percentage of the width, so that percentage of 5, which was just down here, so 5 times that decimal. That gave us the 3.194, and that's how far into that width we had to go. So we added it to 105 in our final step, and that gave us 108.194 recurring. So there we go. Right, quite a lot to go through for estimating the median from a histogram. Certainly not an easy question, but hopefully that there gave you a method for how to go about working this out. Okay, so in this question here, we've not actually been given the lowest, highest and median, etc. We have been given a list of the 15 people waiting to be served at a garden centre here and the time in seconds that they spend. So fortunately it's been put in size order, but we're actually going to have to find the values ourselves. So it's not too bad. We've got the lowest one there, 5, and the highest 44. Obviously we'd have to rearrange this ourselves if it wasn't put on there, but let's have a look at actually drawing the box plot. So let's just start putting some of the things in that we know. So 5 is the smallest, 44, the squares go up in ones this time, so I'll try and do as best as I can. Let's have a look. Looks like 44 there. And then we've got to find the other pieces ourselves. So we'll start off with finding the median. Now there's 15 people, so obviously to find the median here, we just add 1 and halve it. So 15 plus 1 is 16. And we're going to divide that by 2. So 16 divided by 2 is the 8th person along. So let's just go along. We've got 1, 2, 3, 4, 5, 6, 7, 8. There we go. So 25, and that is our median. Let's just label that in. There we are. So the median. So 25 is obviously halfway between 20 and 30. Let's put that one in there. And let's find our next one. So using what we did a minute ago, 15 plus 1 is 16. And if we divide that by 4, that'll find us our quarter. So we've got 16 divided by 4 this time rather than 2. Or obviously you could just halve the 8 and that gives us 4. So we're looking for the 4th person along. Let's do this in a different colour. So 1, 2, 3, 4. There we are. So 14 is our lower quartile. So 10, 11, 12, 13, 14 as best I can. that's there. And we can go 4 from the other end to get our upper quartile. So 1, 2, 3, 4. There we go, so 30. Let's plot that on 30. There we go, and then let's join that up as a box plot. There we are, so joining that up and finishing it off with those last little bits there. Right, okay, there we go. So if you haven't seen obviously that process before with finding the median, because sometimes people just cross off from either end, just something to be thinking about there. Obviously you can apply a little bit of logic. If you have 3 people standing in a line, okay, you don't just halve 3 to get the middle, because obviously the middle is that second person there. You would do 3 plus 1, which is 4, divided by 2, and that tells you it's the second person that's in the middle. So I'm just applying that logic, obviously, from that little simple example, obviously, onto these 15 people standing in a line, and the same for the quarter of the way along, okay? So just add 1 and halve it, or add 1 and divide it by 4 to find out where the quarter is. Right, okay, so now we've got another box plot below. It says the box plot shows the distribution of the times that people waited to be served at Green's garden centre. It's obviously different to Rose's garden centre. And it says compare the distribution of the times at Rose's and the distribution of times at Green's. Okay, so if we have a look at what we've got here, there are 2 things that we're going to want to actually compare when we're looking at these box plots. One of those things is our big key important average here, and that is the median. And then the other one there, we're going to have a look at the interquartile range, but we'll discuss that as we go along. So all we want to do is have a look who has the higher median, or the other way around, who has the lower median. And the higher median is here in Rose's. We know that that median there is 25. And if we have a look, it looks like this one is 21 at Green's. So I don't have to mention any numbers here. All I have to say is Rose's garden centre, okay, has a higher median. There we are, and I want to add one more little bit of information in here, and that is adding a bit of context. So this is all about the time that they wait in the queues, I'm guessing. So I just want to say Rose's garden has a higher median wait time. There we go. I don't have to mention any numbers. I'm just making a comparison and bringing in a bit of context. So I'm not just stating a random fact here. I'm saying that the actual median wait time is higher at Rose's garden centre. Now there's one more thing that I want to compare, and that is the interquartile range, okay, which is a measure of how spread out these wait times are. If you think about what that interquartile range actually is here, this little gap in the middle, that's half of the data there. It's the central half. There's the first quarter on the left, then half of the data in the box, and then the last quarter at the end there. So that interquartile range, and again, I don't have to mention any numbers, but it goes from 14 up to 30. So that's an interquartile range of 16 there in terms of that wait time. Now, if I have a look at the one below, there we go, that is ranging from 12 up to 35. So 35 take away 12 is 23, 35 take away 12 is 23, there we go. So the range there, or the interquartile range, is greater at the Green's garden centre. So I would say the interquartile range, or the spread of wait times, there we go, or I could say it in a different way actually. I could say the wait times are more spread out at Green's. It probably makes a little bit more sense just to shorten it down. There we go. The wait times, okay, are more spread out at Green's. There we go. You could even say shown by the interquartile range. But obviously thinking about what that means, it means that obviously at Rose's garden centre there, with 16 being the interquartile ranges, those times are a lot more compacted into the centre there than obviously Green's that are a little bit more spread out. There's obviously an interquartile range of 23 in between those time frames there, shown by the box plot. So there we go. That is our last little bit of comparison there. So always make sure you compare the median, and then always make sure that you compare the spread, again, which is shown by the interquartile range there. I've just realised that doesn't really look very good. It doesn't really look like the word spread. There we go. Okay, so the wait times are more spread out at Green's garden centre. The scatter graph shows the marks of 12 students' tests, and if we have a look at the graph, we can see we've got the science marks going up along the y-axis and the maths marks going along the x-axis. And it says here the table shows the marks of 2 more students, and we have 2 students here where we have someone that gets a maths mark of 12 and a science mark of 14, and then we have another student below there that gets a maths mark of 17 and a science mark of 20. Now in part A of the question, it then says show this information on the scatter graph. So we need to plot these 2 points. So we'll start with that yellow one there. We've got a maths mark of 12, which we can find down the bottom here of 12. And then we're going to go up to 14, and we're just going to follow what they already have, which is just putting a little X on that point there. For the one below them, we have a maths mark of 17, which is over here, and we're just going to go up to a science mark of 20. So following that line nice and carefully, you can always lay your ruler down if it helps, just to make it a little bit more accurate. And there we go, that's right at the top there. So there's our 2 points plotted, and that's part A completed. Now before we move on to the next part, there's something that I would advise you to do no matter what the question is asking on a scatter graph, and that is to draw your line of best fit. Do check to see if you have to plot any points first, as that might almost change your line of best fit slightly, but always draw a line of best fit. There is very rarely ever going to be a scatter graph question where you don't have to draw a line of best fit, so we're going to draw that in straight away. Now I don't have a ruler here to use on the screen, so I'm going to draw my line of best fit as best as I can. But just thinking about a line of best fit for the moment, a line of best fit is almost exactly as it sounds. It is a best fit going through the points. It's not an exact line that's necessarily even going to go through a single point. It's just going to go in the general direction of the points. Now what we could do is we could just go for it. Okay, so I'm just going to draw one in as I think would be relatively okay. So there we go, there's a line that's pretty much going through all the points. But when it comes to a line of best fit, everyone's is going to be ever so slightly different, or can be ever so slightly different. Because I could angle that ever so slightly more, let's think of how to phrase this. I could make the gradient slightly less or slightly more. What I mean by that is if we get rid of that one, we could have it going maybe like this. Or I could get rid of that again, I could have it going slightly higher up, maybe like this. Okay, and both of those lines, or all of those lines there, would be absolutely fine. Now the general rule is you want to have about the same points above and below the line. What I mean by that is these little crosses we have on the graph, we want about the same above the line as below the line. Now you don't have to rigidly stick to that, but we do want to get it in that sort of direction. Okay, so having a look at that, what have we got? We've got 1, 2, 3, 4, 5, 6 above the line, and 1, 2, 3, 4, 5, 6, 7 below the line, with a few of those being very, very close to the line. So that would be absolutely fine. You don't have to be too stressed about getting this line absolutely perfect. Obviously what we don't want to see though is a line going in the complete wrong direction in the complete other way. Okay, that obviously would be incorrect there. We do want to get it in the general direction that those points are going in. So we'll get rid of that one. There's our line of best fit. Now we can have a look at part B. And it says, what type of correlation does this scatter graph show? Now there are three types of correlation really. We have a positive correlation, we have a negative correlation, and our third one would be no correlation. And it's quite unlikely that you'd be asked a question on a no correlation scatter graph, as there's not really much that you can do with them. But we will primarily, and we will be focusing only on positive and negative correlations in this video. Now, this particular graph here we have is called a positive correlation. And if we imagine that we were sort of standing over here, it's almost like we have to walk uphill. Okay, so if we're standing over here, it's a bit of a silly analogy really. But if we are going from the y-axis and we are walking to the right along the x-axis, we'd have to walk upwards. And that right there is what we call a positive correlation, where the line is going upwards. If it's sloping the other way, like that little line I drew a second ago, that would be our negative correlation. And it would just kind of mean we would have to go downwards down the line, obviously using my little person analogy there. But let's get rid of that. So we have two options. Sloping upwards is going to be a positive correlation, and sloping downwards is a negative correlation. So in terms of this question, what type of correlation does it show? All we would have to say is positive. Okay, now this is just my personal preference, but I always like to stick that word correlation with it. Just in case it doesn't say the word correlation in the question, we would be wrong then just to put positive. If it just asks what sort of relationship it had, we would have to say positive correlation. So do get used to just including that word and just saying a positive correlation. I've not got much space there, so I'm not going to write it in. But had it have not said the word correlation, we'd have to make sure we write that in. So there's another key little point there. You don't want to be missing a mark for not writing that word. As it does say correlation, I'll just write the word positive. Now on to the last part. It says another student's mark in the maths test was 15. Estimate the science mark for the student. Now this is easy enough. All we need to do is find that information on the axes. So we have a maths test was 15. So if we go along the maths marks and we get 15 down here, all we're going to do, and do show this working out, we're going to get a ruler and we're just going to go up to our line of best fit. And this is where everybody's answer will slightly change depending on your line of best fit. And once we hit that line, we're going to go across and read that off the axes on the left. Now I've kind of sloped up a little bit there, and again we do want to make this accurate as possible. I haven't got my ruler, but we'll do this with a ruler. There we go, and we get a mark of 17. Now depending on your line of best fit, it might have gone just over 17, so it might have been 17.2, it might have been 16.8. Whatever value you have, you read exactly what it is off the axes there. So for me, for my little estimate there, I'm going to go with 17. You don't have to necessarily round it to the nearest whole number if it does go over or just below. You're just going to read it exactly as it is on the axes. So for that one there will be a little range of values that people are allowed. So maybe it might range from 16.6 to 17.4, something like that. Okay, but obviously you will get the marks for this sort of question as long as you show this little dotted line and exactly how you got your answer. That will take into account that if your line of best fit was just slightly off, or you've done it a little bit in the wrong direction, that you did know what you were doing and you're using the correct method to find your estimate. So there we go, that's pretty much everything to do with a scatter graph. There is one more thing that we could have. We could actually have to plot maybe a point that doesn't fall within this general trend here. Let's say, for example, it said somebody got, I don't know, 18 marks on their maths test and 14 marks on the science test. And if we plot that point, that would be just here. Now that would be called an outlier. Okay, something that doesn't follow the general trend. And it might ask us about that. It might say, you know, why was this point out of the range, or give a reason why this point was over there. We might just have to give a little logical explanation, something along the lines of, and it can sound really sort of silly, but you might just say, well, perhaps that student had a bad day on the science mark, or perhaps their maths is just a lot better than their science. Anything that's logical that fits into a reason as to why this point might fall out of place would be absolutely fine. Obviously nothing silly there, but just thinking about something logical in real life. Likewise, we might be asked to predict somebody's mark that got 21 on their maths mark. Now this graph obviously doesn't go up to 21, maybe 21 wouldn't exist on this test, maybe it only went up to 20. But let's say the test was out at 30 and it said to predict somebody's science mark that got, I don't know, 25 on their maths mark. Now we would have to say in that situation that we couldn't, because it's outside of our data and it's outside of the graph, so we couldn't actually make that prediction because we don't have any data in that particular range. Okay, and that is the end of the paper 3 revision video. Don't forget to go into the description and check out papers 1 and 2 if you haven't already. And if this was useful and helpful, don't forget to like the video, don't forget to comment, don't forget to subscribe to the channel to keep up with all my latest updates, and I'll see you for the next one.